Here I am.
Hi everyone, this is Caroline Griffin with RIoT. I just want to thank you all for being with us today. We have a great group here with us today. We're going to start off with the Code the Dream group brought to you by Google Fiber, and then we'll go into a presentation with SAS and then partners Clario and Tago.io. Which will do separate presentations. And I would like to remind everyone that this session is sponsored by Dual Boot Partners. So we're really excited to have Tina Cochran here today with us. And please stay tuned till the end of the session because we will be giving away a water-resistant anti-theft travel backpack courtesy of Dual Boot Partners. Just real quick housekeeping reminders before we get started. Everyone will be on mute, but I encourage you to use the chat box, which is open for any questions. We'll make sure that those questions are answered at the end of each presentation. This will be recorded, so please stay tuned for this recording on RIoT's YouTube channel. I just want to remind everybody that this is usually our Developer Day session, but with the current pandemic going on, we took this opportunity to really expand this into a month-long educational session. So we're just really thankful to everyone here and for everyone throughout the whole month for joining. This is just a great way for people to connect, learn, engage, and I really encourage everyone here, if you have any questions for any of our sponsors or speakers, panelists, please do reach out to them one-on-one, or I'd be happy to connect you afterwards. So without further ado, I know you all are here to see the wonderful speakers, so I will pass it off to Lori and this great group of women here today with Code the Dream by Google Fiber. Thanks, everyone.
Hi, thank you so much, Caroline, and thanks to everyone. Thanks to all the sponsors. I am Lori Khamala. I'm the Director of Programs at Code the Dream, and really grateful to be here and have the opportunity to share some about our program. Thanks also especially to Google Fiber and all the rest of the sponsors too. Glad to have everybody this morning, so we get to share our innovative model and some of the recent projects that Code the Dream has been working on that not only serve our community and respond to the COVID-19 crisis, but also are really propelling forward the tech careers of the next generation of software developers. I'm going to be moderating our panel this morning, and if anyone has questions, please feel free to type them in the chat. We are going to take questions at the end, but please enter your questions at any time. We're going to start with a brief round of introductions just so you can see who we've got from the team this morning. So Daisy, Andrea, and Alex, I'm going to ask you to share a little bit about your background and also, because there's been so much stress and negativity lately, share one thing you have enjoyed about quarantine in your brief introduction. I'll turn it over to Daisy.
Hi, everybody. My name is Daisy Magnus-Aritey. I am Program Director at NC Idea, where I manage an ed tech product called the Ice House Entrepreneurship Program. I am a Code the Dream student from 5 years ago when the program was just getting off the ground, and I've been involved in various ways since then. One thing that I have enjoyed within quarantine, is that the question? I have a few things. One is giving presentations in my bare feet. Not having to wear heels is fantastic. And then also just spending lots and lots of time with my children.
Hi everyone, my name is Andrea Hernandez Guzman. A little background about myself. I'm originally from Mexico, came to the US when I was a year old. I'm currently a DACA recipient, and I've been living in Durham, North Carolina, ever since I was a year old. I've been working at Code the Dream as a software developer for over 2 years now, but my journey with Code the Dream starts a bit further back in the summer of 2017, right after graduating from high school. I started taking 6 months of free programming classes at Code the Dream. And after completing the classes, I got the opportunity to work here as an intern, where I worked on building apps, such as apps to organize free rides for seniors, and apps to provide support for migrant farm workers. Now working full time, I do still get to work on different projects, but I also work on mentoring some of our newer interns. And yeah, that's a bit of my Code the Dream journey thus far. Quarantine, something that I've enjoyed, perhaps probably not commuting as much, has been nice. But yeah.
Hi everybody, my name is Alex Rodriguez. I'm originally from Mexico. I've been in the US for about 17 years now. So after high school, I didn't have many opportunities because there was no DACA at the time. So I had to work multiple jobs just to make ends meet. But then I learned about Code the Dream and I took the classes, and I've been with Code the Dream for the past 2 years, working just recently full-time. I'm a web developer and a operations manager. I'm working at building websites for nonprofits, businesses, and community groups. One thing that I enjoy during the pandemic, I guess, it was the commute as well. I was spending about an hour in traffic and spending time with my son.
Awesome. Thank you, Daisy, Andrea, and Alex. Yeah, I agree. Not commuting is awesome. And Zoom meetings in socks or bare feet is also awesome, but I definitely miss the camaraderie with my awesome coworkers. This is just going to be a conversation here. So Daisy, you have been really instrumental in the shaping of Code the Dream. And as you mentioned, you've played a lot of different roles in the organization, from student to program director to board member. So could you share with folks a little bit more about the Code the Dream model and what makes it innovative?
Sure. So the model is really simply to create a pathway to a career in tech for people who are underrepresented, people who are traditionally underrepresented in tech. And so that's everybody you see on the panel here. We all have an immigrant background. We all identify as female. We are all, Black and brown people who traditionally, our numbers in tech are not high. And so Code the Dream exists to create a pathway for people like us who are looking to get those, really fulfilling, rewarding careers in technology. So our goal is to create pathways through education, innovation, as well as hands-on experience in order to use tech for good. And so tech not only for good of our community, but also good for the developers and the students who go through our program. So there's this quote that I read recently, and I wish I had discovered it a long time ago, because it just fits the Code the Dream model so beautifully. The quote is, "The closest to the problem are closest to the solution, but furthest from the resources and the power." So I'll say that again. Those closest to the problem are closest to the solution, but furthest from the resources and the power. So at Code the Dream, we want to really bridge that gap. We want to work closely with those who are close to the problem, knowing that they have the solutions, that they know more than we do if we're standing outside of the problem. But also we want to give them the power, the resources, the technology, the education, the know-how in order to develop those solutions, and then to disseminate them widely. So the way that we do that, we offer 6 months of free classes. So our classes are never for a fee, so everybody has an opportunity to participate. Further, our classes are in the evenings and on weekends, so people can kind of fit them into their schedule. We recognize, like Alex, we have a lot of parents who are working multiple jobs and trying to make it happen. And so that traditional school calendar doesn't work for them. So we try to make it as accessible as possible. Once people finish those 6 months of classes, we invite them on to be paid interns. And that's where they work 40 hours a week for Code the Dream. They're working with senior developers, they're working with each other, and they're building real world apps. And so it's much more intensive than a tutorial or building a one of those classic sort of to-do list apps that you get on every tutorial, but you're really solving these complex problems. You're dealing with legacy code, you're dealing with clients and changing priorities and deadlines. And so they really get that almost kind of a fire hose of information. But through that, they're really able to grow their skills and to become developers.
Awesome. Thank you, Daisy, for that great introduction to Code the Dream. We'd love to now kind of show off some of the awesome projects we've built. So we're going to share some demos. Andrea, we're going to start with you. When COVID first started, you were involved in a project with the Durham Public Schools Foundation that was addressing food insecurity among students. Can you tell us a little bit about that?
Sure. So let's see, when public schools across the country shut down back in March, millions of students from lower income families had suddenly lost access to the free or reduced cost meals they depended on. In Durham County, that's roughly 65% of all students. So when Durham Public Schools Foundation came to Code the Dream for help in building out their meal delivery system, we were happy to help. So Lori, could you please start the video?
Yes, I am working on it here.
Back in March, Durham Public Schools Foundation reached out to us to help them build their meal delivery system. One of the big challenges they identified early on was creating a digital sign-up form for families which would provide clean data and accurate addresses. Perhaps the most tricky thing about this project on our end was the timing, because we understood this was going to be an emergency app, and so we really only had 2 days to build it and launch it. And so we focused on building key features such as the address validation, but in addition, the form was also built to take in information such as general information, dietary restrictions, grade levels, and confirmation for text messages. The end result was creating a bilingual form app that has address validation and helps format all of this data more cleanly. And after launching the app, there was an immediate response from families. Within 3 hours, there were over 500 families that had signed up. And since then, with the help of donors, supporters, partners, restaurants, volunteers, school leaders, and the app, more than 375,000 meals have been delivered. Overall, this was a really rewarding project to be a part of, and I'm pretty happy it was able to help make an impact in my community.
That's awesome. Thank you so much, Andrea. It's such a great example of where Code the Dream is really stepping in to partner in a really relevant time and a really relevant project. So thank you for sharing that. Let's see. Yeah, we wanted to share one other project. We'll do one more demo now. One other project that is also responding to the COVID-19 crisis. So Alex, can you share with us a little bit about the Face Mask Warriors project?
Oh, sure. So back in March, as you already know, when the pandemic was just starting, there were not enough face masks. So I was excited to work with Face Mask Warriors. My mentor, Kristen, and I worked for 2 days straight to get the site done. It was hard work, but I was happy to make a difference. Now I'm going to show you the site. Can you play the video, please, Lori? As you can see, over 700,000 masks have already been made and distributed by over 17,000 volunteers. One of the most unique things about this site is that it's actually integrating the needs of the face mask warrior groups in each state, so more than 50 different groups. And it was very important to them that the website provide a way to connect with each individual group. So here you can connect to the Facebook groups in each state. And over here is where you can request masks, volunteer to make masks, or become a drop site or runner. and each state has its own database for volunteers, and we help them find ways to integrate their data for national reporting while also maintaining local control over the individual database. So for example, if you want to volunteer to create masks, you choose your state. Once you submit this form, the data goes to an online database called Airtable where the local coordinators can connect to the volunteers. Another features in the site include a collection of news items, a way to donate, and a page that shows volunteers how to make masks. We are excited to continue working with Face Mask Warriors to help get masks for everyone in the country. Thank you. So even though we just had a small part, we are really proud to have been involved in some effort to the COVID-19 crisis. And efforts like Andrea on building the Durham Public School Foundation to make sure all kids get fed, and efforts like my building the website for Face Mask Warriors, we hope that we can help to make a difference in these challenging times. Thank you.
Thank you so much, Alex. One of the things I really appreciate about Code the Dream is our ability to, like I said, just partner with groups in the moment to be able to create really relevant projects that are responding to the need. So both of these examples, both these projects had to be cranked out pretty quickly, but we also work on extremely complex projects that can last years. Like one effort we're working on at the moment with Duke University and the Federal Clinical Trials Database. Unfortunately, Crystal was going to share with us about that more, but she lost her voice and could not join us this morning. But yeah, there's lots of things we do. So Andrea, I want to go back to you for a minute. I know that you went from almost, when you started out a few years ago, knowing almost no coding to now being senior coding staff at Code the Dream. And you've been able to work on some lots of interesting and compelling projects, as well as mentoring new interns. Could you share some of the other projects that you've helped develop while you've been at Code the Dream?
Sure. Other projects, I worked on an app called Conectate Carolina that is designed to help North Carolina farm workers be able to locate resources in their areas and alert them of natural disasters. Ultimately, the goal is to help improve farm workers' health and wellness. But actually, that app had previously started from previous Code the Dream students. And I got to join along to help implement the mobile version of the app. So I have a slight soft spot for that app because it was really my first app where I had to go through the whole process of getting to work on a small team, communicating with the client on the requirements, building out the app, and really going through the whole process of launching the app. So it was really cool to be able to take everything that I got to learn from my Code the Dream classes and get to build a full-fledged mobile app that helps impact the community.
Awesome. Here's one other, we'll just take this question right now that just came in. Can you share what kind of coding we do at Code the Dream, Andrea?
Yeah, so let's see, for me, when I was taking the classes, I started learning. Primarily, we focused on the fundamentals of JavaScript, and then afterwards moved on to the JavaScript frameworks called React.js. And then during my internship, I really got to touch on React Native, which was more focused on mobile development. And that's basically been, for me at least, more focused on the front end, some of the coding and programming languages that I've gotten to learn.
Yeah, it's awesome. And for that mobile development with React Native can be develops for iOS and Android. And then on the back end, we our focus language is Ruby on Rails with the framework. Thanks, Andrea. Alex, what about you? What are some of the other projects that you've worked on that have meant a lot to you while you've been at Code the Dream?
One of the, well, they've been a few, but one of the ones that I really like doing and was an app to help victims of domestic violence. So I had the opportunity to work with the North Carolina Coalition Against Domestic Violence. And we created a toolkit to provide resources and training for healthcare providers to help the victims of domestic violence.
Awesome, thank you. That's great. I never get tired of hearing about these projects because I don't know, I think the quote that Daisy shared really captures it very well. Again, I'm just gonna repeat it again because I like it so much. Those closest to the problem are closest to the solution, but furthest from resources and power. And yeah, with the Code the Dreams model, which we consider a win-win model where individuals get that experience to launch their tech careers and where communities benefit from the technology that our developers create, I think we can help close that gap, Daisy said. Daisy, can you share with folks how to get more involved with Code the Dream? I hope that everyone, all 30 people on this call, are just eager to find ways to get involved. So how can folks get involved?
Sure. So we have mentor opportunities, and when we talk about mentoring, there are kind of two separate ways to define that. So our classes are 6 months, and we try to provide as much scaffolding and personalized instruction as possible. And so we are always looking for mentors that can serve as lead teachers or to kind of small groups of students. So, 5 or 6 students, and then you work with them and they can check in with you when they're having difficulties with the material. So that's one way to get involved. Another way to get involved is to serve as a tech lead for one of our projects. And so you've heard about the projects that we work on, and so if any of that sort of social good work motivates you and energizes you, and you're looking for a way to plug in, that would be a great way to volunteer with Code the Dream, would be to lead a project like that. Another way to get involved would just be to simply donate. Code the Dream is a nonprofit, and so sharing the idea and sharing funds and connections is a great way to help us continue to do this work and propel us forward.
Awesome. Thank you so much, Daisy. And I've just posted our website in the chat, and on our website, there are links to donate, of course, as well as links to volunteer. And one more thing that I'll mention is just if anyone is looking for partners in building their app, web app or mobile app, consider us. We do a great job, and we've got some awesome developers. So in the last 5 minutes, I think we'll just take some questions if there are any more. Let's see. Yeah, feel free to ask any, fill in with any questions. And in the meantime, I am just gonna ask our developers here a few more. Oh, let's see. Are there specific guidelines on the kinds of projects you will accept? Daisy, do you wanna take that question? Oh, you're still on mute.
Sorry, I think that's the quote of the year. You're still on mute. We don't have specific guidelines about projects that we will accept. We are looking for projects that do social good. That's really our wheelhouse. But anything that will further our developers' knowledge is always an interesting and worthwhile project to us. And so, yeah, there's nothing specific. We're willing to have the conversation with just about everybody and see what we can offer to your group.
Absolutely. We do really large, complex projects entirely. And we also we have certain projects we work on we are maybe just doing one, big institutions will sometimes contract with us also to just do smaller portions of a large project. So, as we wait to see if any more questions come in, I will just ask Andrea and Alex to share what you have enjoyed most about working at Code the Dream. Alex, do you want to start?
Sure. I just love the fact that Code the Dream not only helps people like me, but we also help the community through the technologies we create. And we're like a big family, so very supportive.
Yeah, and I think I could probably tag along with that of probably my favorite thing about Code the Dream tends to be the community. There's just a bunch of different people from different walks of life. So it's always great to just learn all of the new people and how they are interested in both doing social good and also becoming developers. It's really cool.
Andrea, I'll just ask you sort of a follow-up. How has that shifted during COVID when everyone is remote now? What does that look like, that community and that working together with everyone being remote?
Yeah, it is a little bit different being all fully remote. I definitely miss having the in-person interactions, but it has benefited us in some good ways of having it be more accessible for everyone, really, even our remote interns as well, to really become more connected so that we can all kind of be on the same page and also not feel like anybody's being left out. I would say it has brought some good benefits of getting to all be remote.
Yeah, we didn't mention, but Code the Dream actually did go national last year. And so we actually have opened up our classes and our internship to folks from all over the country. So at the time, right now, we do have interns in Baltimore and Chicago, in California, and some other places. So, so yeah, actually going remote has, like Andrea said, I think really made our community a little more accessible to those who were already remote.
Lori, there is a question.
Yes, yes.
Have you partnered with any specific cloud service providers for data analytics and visualization?
I don't think that we have. I don't know, Daisy or Andrea, is that a question you can answer?
As far as I know, we have not. Andrea, have you done so in any of your work?
No, I have not.
We would be open to it though.
Yes.
Yeah.
And who's the best person to reach out for volunteering opportunities?
You can probably reach out to me, and my email is up there, lori@codethedream.org. You can also fill out a form on our website, just codethedream.org/volunteer. And you can see some volunteer opportunities outlined there, or just reach out to learn more. And I think we are now at time. So I want to thank my awesome team, Daisy and Andrea and Alex. And thank you so much to Caroline and all the folks at RIoT. We really enjoyed getting to share with you all today.
Amazing. Thank you so much, Lori, Daisy, Andrea, and Alex. You ladies were phenomenal. Just really motivational for this morning. Appreciate your time. Awesome. While Steve and Tom are getting set up with SAS, I encourage you to please, reach out to these ladies, volunteer, get involved in their projects. Just really awesome things that they're working on. Without further ado, I will pass it over to Steve and Tom. Thanks for joining us today.
Great, thanks everyone. And Lori and Daisy, Alex, Andrea, thank you for that great session on Code the Dream. I learned quite a lot myself. What we'd like to do now is talk a little bit more about maybe some of the technologies that Code the Dream is working on and teaching through their internships and their outreach programs. And specifically, we're going to be talking about machine learning models and streaming analytics on the edge and in the cloud. So first, a couple of real quick introductions. My name is Steve Sperano, so I am the product manager at SAS. And the areas that I oversee is a portfolio specifically for our event stream processing technology. And that ESP technology is a portfolio of capabilities. And those really address these needs around streaming analytics and our ability to push machine learning and artificial intelligence out to the edge, as well as to the cloud on streams of data as they're arriving. I'll let Tom go ahead and do a quick introduction just on his background and his role today.
Hi, I'm Tom Tuning here. I am a solution architect here at SAS, and I'm also in the IoT division. I have a background in systems management and IoT. So when I came to SAS, I had to learn a whole bunch of all about streaming analytics and analytics in general and how SAS works and everything. So what I'd like to do today is maybe try to bridge the gap from what RIoT talks about, where it's IoT focused, and what traditional SaaS is, the big data in the cloud kind of vendor that that provides great platform products and manages the whole life cycle. So I'm going to show later on in this conversation is how some really cool projects that you can do on the edge and in the cloud.
Very good. Thanks, Tom. Yeah, and Tom mentioned, some of the technologies we'll be talking about. There'll be a combination of open source technologies and also some of the benefits and approaches that SaaS provides, obviously in the marketplace with the technologies we provide with our SaaS Via platform. But after us, there'll be a session from Clario. And look forward to hearing what the folks from Clario, like Ted, are going to be talking about on the heels of what we'll see today. So first, obviously, this being a RIoT event, just a real quick kind of primer on IoT and the Internet of Things. And you've probably seen charts like this before. It really gets to some of the challenges associated with the volumes of data. They're arriving from lots of different places. And those different places, those different things in the Internet of Things can include internet users, so web traffic. A lot of our customers deal with interactions with their customers as they're on their website. So sometimes those things are actually people, and it's not the wearables, it's not the planes or the hospitals or those connected devices in those environments, but it's actually the people on the internet, on their websites, interacting with B2C sort of commerce sort of applications. But of course, other connected things like airplanes and some of the volumes of data that they create, but also not just the volumes, but the speed at which they create this data is really awesome. We're working with some partners right now on the connected hospital space. And hospitals, they tend to actually have quite a few investments in the healthcare space. And much of that focuses on, believe it or not, asset optimization and asset utilization. We often hear stories from this partner of ours where the hospitals actually struggle with where is all of these different pieces of equipment, where do they exist? They paid a lot of money for these assets, they've invested a lot of money in this infrastructure, but oftentimes they can't find these assets. And these assets include everything from the very high-tech beds that exist in hospitals, to drug carts, to glucose monitors, to heart rate monitors, and they're looking for better ways to track these assets. But tracking those assets out on the edge means lots of data has to be collected, brought in, and managed accordingly. You've seen the autonomous vehicles as well, and those connected cars, but it's not just where the cars are in the self-driving cars and the ability to navigate and navigate safely, but also the onboard mechanisms for things like predictive maintenance. How do we ensure that the vehicles stay running and are optimal as they operate and prevent breakdowns and prevent loss of basically operations? And that you can see also not in the connected car space, but in the transportation and logistics space. And factories are a similar mechanism. That is, we want to keep the machines running, but we also want to be able to increase quality and reduce waste and reduce scrap. And that's a big part of optimizing quality and using analytics to do those things. But many times folks ask, well, I'm connecting all of these different devices together. Where's the value in this Internet of Things? Where's the value with what we want to capture about what these machines are doing? I've touched on a little bit of that, but if we break that down and try and figure out how to obtain value from this, it really comes down to these three areas around sensing, understanding, and then action, or acting on what we've gleaned as insights about the data that we do have. And if we start with the sense piece first, That's about ingesting data from those different devices, from those things, from those humans, the airplanes, the hospitals, the assets. And we need a mechanism to ingest that data. And those can be a series of device manufacturers that you integrate with. Those can be adapters or connectors, as we call them in our event stream processing family. But once I bring that data in, and this is where, in terms of evolution, a lot of companies are today. They're bringing data in, but they haven't applied analytics, for instance, to gain insights and understand exactly what's happening with all of that data they're bringing in about those things or people that they're interacting with. So by applying analytics, we can start to gain those insights. So analytics is really the key to driving insights and understanding about all of that data we're collecting. Because if we're not applying the analytics for better understanding, better
Payment
insight,
on shipment.
then what we'd find out is basically that we really don't have that understanding to
Customer service.
To be able to then act on that information. I think someone's off on mute, so if we could go ahead and just make sure everyone's on mute until there are questions or other folks. Sorry about that. But then action, and that's a key part of this as well. It's great that we can apply analytics and get insights and have better understanding of how these things are interacting out there. But if we can't make a decision based on those insights and act on it to correct either maybe a potential fault that we've predicted in a machine and react proactively, or deliver a better offer to a customer to make their experience better, then we're just calculating predictions, or we're just calculating anomalies, and we really haven't really completed that life cycle to then act. And then our actions can be fed back into the system as well. And when we apply all of these things, we can then start to realize this value behind this, which is, how do we improve the efficiency of our operations? How do we optimize those efficiencies? And more importantly, can we create new business models? We see a lot of this with digital transformation, which clearly an overused term, but with these new business models, our customers are starting to come to us and have been asking, how can I leverage all of this data that I'm sensing and now want to apply analytics to make and create better actions? How can I turn that into a revenue stream? How can I monetize those actions for better interactions, again, with my customers, or sell that information that I'm maybe already collecting and start to sell it back to those that I've sold products to for new services, for new optimization models. And all of this has been estimated by various analysts for the actual economic impact, which is huge. But as I mentioned, all of this is driven by analytics, the analytics on that data that we've sensing to create understanding and then drive action. And AI is obviously a big term that we've heard about. It's been around for a while, since the 50s and 60s, with different programs that were first written to, like Perceptron, to be able to play chess, for instance. But AI is really the science of essentially training systems or building models that can then emulate human tasks, but do this through learning and automation that is continuously improving themselves. So if we think about it, there's a learning aspect to it. So learning meaning that I'm continually learning from past actions and improving my responses. And then there's an adjustment phase that as I get new inputs, I can adjust what I do in terms of an action based on that learning model. And then of course, drive an action based on that. Be able to take an action or make a recommendation, oftentimes you hear, about that data that I have collected. But we also hear about this term called machine learning, and think of machine learning essentially as just a branch of AI. AI being, or artificial intelligence being, an umbrella term. Machine learning is essentially about learning from the data that I do collect and looking for those patterns, and again, driving action by making decisions, but doing that with minimal human intervention. And one of the big differentiators between machine learning and what you will see with deep learning is machine learning requires some structured data. That is, the data needs to be tagged. If you're looking at a collection of photos of dogs and cats, let's tag the ones that we know are dogs and the ones that we know are cats. And from that data, that structured or tagged data, the system can learn. And we can build better and better models as we collect more data and bring that in. Where deep learning comes into play is it's a type of machine learning, a specialized version. So it's used in speech recognition or object detection and classification using images or photos. But deep learning differs in that it needs larger amounts of data, typically. And these are somewhat generalizations, but typically needs lots of data. The other important characteristic is the data doesn't necessarily have to be structured. So it can use different concepts about the data to start to categorize and contextualize the information into different categories and use that then to drive actions. And one specialization around deep learning is computer vision. And that's what we'll talk a little bit about today, as well as some of the machine learning aspects. That is being able to use vision and be able to capture images and objects and identify what they are, process those images, crop those images, and be able to detect where images are in those pictures or videos that we have collected. And when we look at computer vision, as we've said, it's a deep learning method or technique to categorize these objects and these images together. But where we start to see its application and real benefit in industry is in retail. So identify different products and categorizations. You've seen some of the videos where we're watching individuals.
I'm sorry, I don't have an account number.
Let's go ahead and make sure we're on mute as we're talking.
I'm trying to ship a package and it's denying me, it's failing.
The other aspect is in safety and maintenance, where we're identifying where workers may be in a factory, and are they in that particular space, and should they be in that space? And if they are in those spaces, for instance, are they wearing a hard hat? Are they wearing safety glasses? Do they have a safety vest on? And you can detect those sorts of things with computer vision, which again is a component of deep learning. In medical imaging, we're using this in spaces where we're detecting and doing a better job of identifying things like tumors or different anomalies in x-rays or CAT scans, and be able to use AI and deep learning specifically to identify these and do a better job of identifying these potential problems. Where all of this starts to come together with streaming data or data that's constantly in motion, coming from sensors, coming from things out there, whether it be airplanes or machines or turbines or people on our website, is this term we call streaming analytics. So streaming analytics is taking those AI and machine learning and deep learning, but applying it to data while it's in motion. So the other method or approach that you've often heard is, let's bring all the data back somewhere, store it in some persistent store like a database like Oracle or SQL, and then be able to apply analytics to it and start to score the images that we have. Where we start to see a shift in that thinking is when we think about the Internet of Things and the devices and those different sensors that are emitting all these signals. We want to be able to apply analytics and machine learning and AI on those analytics or on those streams of data while it's in motion. What that means also is we can push the analytics out to the edge. We can push it closer to where the event actually originates or where that image or signal originates, so that we can make a decision faster. Specifically, we don't have to bring all the data back to the cloud or inside our data center, score it, and then send an answer back to the edge. That can be problematic sometimes because sometimes the edge isn't connected. You've got vehicles in remote locations. You may have just a system that's down. Those individual edge devices need to be autonomous and continue to make decisions, adjust on the fly, and not rely on a connection back. By being able to do this decision making on the edge, it also means we don't have to, one, store all the data back in the cloud to process it. We also don't have to transmit all the information back. We can be more intelligent about what we transmit by making those decisions out on the edge where the event actually originates. So now we can identify those patterns of interest, sometimes we call them, as they occur. So that eliminates lag between when I identify an event that I care about, some pattern, maybe certain temperature readings, and when I need to take action. So if I can shrink that time frame between when I recognize an event that needs action and actually taking the action, that allows me to react more quickly, whether it be to customer interactions on websites, or if it means correcting machine behavior on an assembly line to reduce scrap, reduce waste, or in a hospital, be able to identify quickly where assets are so I can improve patient outcomes. But there's obviously challenges with streaming analytics like anything. One, because it's the Internet of Things and there's a huge volume of the data that these different sensors are emitting, we also have a lot of different data types that we have to deal with. So the volumes and the frequency at which we receive these records or events is huge. But also this data isn't necessarily clean. There may be missing values. We may have to detect when a sensor is offline versus when it's simply just not responding. We need to be able to do those imputations and identify missing values and create them on the fly. But we also have reliability issues, as I mentioned. Sometimes these sensors aren't always on. Are they offline? Or are they simply not responding, or are they simply sending the same signal back? But we also in the cloud, for those systems that may be processing this data, need to be able to restart quickly, need to be able to reload themselves, and maximize that uptime for operations. Oftentimes with IoT applications, it's a very operational 24/7, 365 focus. So being reliable, being scalable is important. And scalable is the other big aspect. Oftentimes customers talk to us about enterprise scale. We need to think in terms of cloud scale. That is being able to scale for dynamic workloads that spike at certain times of the day and then come back down, and be able to free up or allocate resources as needed and intelligently determine where this data goes. Do we keep it? Do we not keep it? Again, to manage these spikes in demand. And again, that operational aspect, we need to be able to develop streaming analytics quickly. We need to be able to deploy, but also govern the models that get deployed. How do I monitor how well these models are performing? Am I seeing a degradation in lift? And that is the model not performing as well anymore? Oftentimes our customers will deploy a model, but they built that model with a certain set of assumptions. I expect my data to look this way. This is how I expect my values to be distributed across a certain time frame. If those assumptions are challenged because machines age, people's behavior changes, I need to question my assumptions when I built the model. So we need to monitor as that data is changing. Is the data changing, and is the model still the best model? And have automated processes in place to be able to push newer and better models that have been trained and pushed out. So the life cycle behind how to do this, the traditional approach, and you've probably seen this, you've probably experienced it yourselves. We're collecting data, we're performing extract, transform, and loads of ETL into fixed data stores. And it's in those data stores that we typically train models and then score that data that's in those data stores. So we go through a model development phase and then redeploy our model back into the data storage. That can then drive alerts, reports, decisioning, actions, and so forth. Works very well, has worked for many years, and continues to work today. Where we start to see this change is when we look at that sense, understand, act model that I talked about in the beginning. What gets introduced is now streaming data along the bottom of this grid. And what we introduce is the ability to now stream models, so I can still build and score or create scoring mechanisms on fixed data. That's still a possibility. But I not only want to deploy into my data storage mechanism, but I want to take those scoring models and I want to also deploy them into the streaming execution environment. So that means I need to take and leverage all of the training that I've done for model development, use it in data storage if needed, or create new models and deploy them into the streaming world. That means now as data arrives in real time, I can enrich it with data storage or fixed information. Maybe that didn't come in on the inbound transaction, but I can be scoring that model as well in real time to drive real-time alerts and reports and decisioning. And another aspect is to introduce online models. That is, models that don't have to be trained ahead of time. This adds another aspect that I can now point analytic algorithms at data as it arrives to do things like clustering. So I don't have to have pre-trained models to be able to identify clusters of maybe customer behavior or anomalies in the detection and my equipment side. I can just do that on the fly. And there's a set of algorithms that are provided, that are available, that you can do this with an online method. When we look at these different pieces and how they work together, we often think in the upper left about building models or building offline my machine learning and my AI. I can then register those models into some model management environment that is a repository, so I know which versions of models I have. And then I can connect that with my streaming designer. So my streaming designer can reach into that model repository, integrate my analytics and business rules together into a flow or a streaming analytics project, and then I can deploy that package into the cloud or out to the edge. That allows me to build models with analytics. It allows me to build real-time streaming analytics models and push them out for execution. And then at the top, as my sensors emit data, I could be looking at that information and deploy and execute these models again in the cloud or on the edge, but not just deploy and forget. I've gone through dev and test and deploy, but I also need to monitor. So as I pull performance results back, I can monitor that model's performance, as I've mentioned, around KS statistics or other metrics like lift, and identify, does that model need to be retrained? And if it does, push the new model back out into this environment. This gives me a complete ecosystem that allows me to develop, deploy, but monitor, and if needed, update that model through retraining or even a new model tournament that creates a brand new model that needs to be pushed out for execution. Some of the technology behind this is our event stream processing technology. As I mentioned, I'm the product manager for this suite within SaaS, and this technology exists in a number of different forms. What we have inside of SaaS specifically is a studio environment. That's my designer tool, my stream viewer, which is my real-time dashboarding, and then my event stream manager, which allows me to take what I've built in studio and deploy it out to production environments, or deploy that package of my streaming analytics and business rules out to the edge or to the cloud. And at the heart of it, of course, is an ESP engine that we'll see from Tom in action. And on the front end, we've got publishing interfaces where data can be published into the engine in real time and access a number of different components and sources. That's really the sense piece. Inside of the engine, we've deployed the analytics. So in real time and in memory, with high speed, so millions of events per second and really low latency, like single-digit millisecond, we can be processing those to get the understand piece. And then downstream, those insights, I can subscribe to the insights I care about. And those insights can come from aggregations, filters, correlations, pattern matching, so that I can then take action based on that. So downstream systems may be things like offer-based systems. So if I've detected that there's a certain pattern I care about a customer's behavior on the website, downstream, if I detect that pattern, I can trigger those offering systems that create things like next best action or next best offer to then determine what is the next best offer to make to this customer in a marketing scenario. If it's a downstream system that needs to monitor production, continuous manufacturing lines, I can do that to adjust maybe speeds of rollers or temperatures in kilns. All of those sort of systems are now tied into this as we ingest data through the pub interface and subscribe for actions downstream using the subscribing interface. Just a snapshot, maybe more of an eye chart than anything else, are the streaming analytics that are available. But what I've highlighted here are some of the machine learning and AI components that are there. But there's a number of other capabilities that are available as well beyond machine learning, the gradient boosting or deep neural nets or convolutional neural nets, which are often used in computer vision, but a number of other aspects as well. And if we look at a couple of use cases quickly about where we're applying this, one interesting one is around, oddly enough, called vegetation management. So in the utility space, we're working with a partner who is trying to ensure, and this is really what it boils down to, they're trying to ensure that in places like California that have a high risk of wildfires due to undergrowth on the power and transmission and distribution lines, they're trying to ensure that they reduce how close that vegetation actually gets to those power lines. What this allows them to do is they're trying to find ways to cut the expenses associated with doing this, which, believe it or not, the market is upwards of $2 billion per year. These utilities are spending on this vegetation management program to protect that grid infrastructure. The end goal being reducing power outages that you've seen they've had to do where they actually force power outages, or the catastrophic fires due to power lines or something they call line spark, where in high wind conditions, these lines emit sparks to the undergrowth that's too close to the lines, sparks wildfires with catastrophic results. The outcomes that they're looking to do is optimize this vegetation schedule by being able to identify exactly where, in an optimal way, where to deploy crews for cutting or spraying to ensure the safety of their citizens. The way we're doing that is using drone technology and computer vision together, deployed to the drone, where we can actually in real time identify what these different species are, identify and start to do predictions on growth models based on if it's a certain type of species, what that growth may be, and then be able to predict how quickly those may be approaching those power lines and creating a bad situation. So we're working with these companies now using HD video and LiDAR technology to be able to do this. So in this short video that's running, what's happening is the drone operator is looking at a screen that's basically coming directly from the HD camera mounted aboard the drone. As the drone flies over these power lines, these distribution and transmission lines, they're capturing today in a manual way those different pieces or different video aspects, and they're actually having to circle after human intervention, that is bringing the video back into the lab, looking at it and trying to ask the human to identify where these high risk areas might be. They go through the video frame by frame and try to identify these species. Instead, what we're trying to do is leverage the drone technology and mounting aboard that drone the event stream processing edge component with machine learning, so that as it's flying over, it's identifying species and calculating distances of these species to those different power lines and marking them as urgent or not as urgent, or just areas that are maybe cautionary you should keep an eye on. It allows them to do this in a way that, one, minimizes the safety issues associated with, sometimes they use helicopters, which, believe it or not, have resulted in serious catastrophic accidents as well. But it allows them to be more precise. So as they fly over, they're able to capture these images and do it in a much safer, but also more precise way, and using predictive analytics to do that. Another is in a manufacturing example, where as we look at this continuous process of a manufacturing line, they're looking to prevent product jams, which result in loss of materials, reduce quality. They're looking to increase or reduce the number of defects and increase the effectiveness and quality and customer satisfaction, actually, of the product that they do produce. Well, one takeaway is that it's not simply one module, that as we take the feeds in from the video coming from the plant floor, it's not simply one process that just says, tell me if there's a jam or not. There's a number of steps that go into this. Tom will get into a little bit more detail about what actually happens around frame extraction and maybe some image sizing and using you only look once or YOLO models. But there's a process that goes into this. And the system supports this process by being able to execute each of these tasks in the order that's needed. The end result being a decision support process at the end, which flags where there might be issues, generate operator alerts, and then potentially even push those alerts and actions off to the PLCs to adjust the line accordingly. The result being this video. So this was an HD camera already mounted inside the factory itself. So as the capture of these videos was coming in, we were using that feed as our data feed to sense and understand now what's happening. What you see in this video are a couple of important things. One, we're identifying that there's an object there. In this case, a piece of wallboard or sheetrock, it's sometimes referred to as. But that's not enough to know that it's an object, but also identify what the center point is and what its perimeter is from those object detection algorithms. As we do that, we're also able to calculate the center point and then calculate the distance between these. As those distances start to shrink, that is, they get too close to each other, the indicators go from green, sometimes to red, or even to yellow. Those can be generating operator alerts to the operator that you see right now in the background is actually working on a bunch of other things, because the poor guy probably has 10 different things to be working on, and he can't be just simply watching the line the whole time. But now he can focus on specific alerts that are the most important alerts, the alerts that might result in defects, damage, or lower quality of the boards on the line. So this is a great example of, one, applying machine learning and computer vision, but then two, also applying all of this in a way that doesn't require us to re-instrument the entire line. We're taking the video feeds that were already there. These cameras were probably installed, if I recall correctly, for safety reasons. If there was an accident, they wanted a record of it, and they want to be able to identify what exactly happened. We simply leverage that same feed now for these other approaches using computer vision to, again, improve quality on this continuous manufacturing line. Before I turn it over to Tom, I will say there is a 30-day free trial. So if you just want to go to sas.com/ESP, you can sign up. You can start playing with some of this technology yourself. There's, as I mentioned, it's free. There's no charge. And also there's a number of different examples that are already available as part of this environment. You can start to play with. There's some relatively simple computer vision versions because we're not using GPUs on this environment. So it's not an example of speed that you'll get, but certainly capabilities are all there. So I encourage you to do that. So I've talked about what you can do. Now let's turn it over to Tom and let's look at how to do a lot of what I've just talked about. So I'll stop sharing, Tom, and turn it over to you.
All right, let me figure out where the share button is. Aha, share screen. All right, can you see my screen okay and hear me okay?
Very good.
Yep, we can hear you, but we can't see your screen, or at least I can't, Tom.
Yep. Just seeing your smiling face.
Oh, really? I could share. All right, let me try this again. Oh, wait. Okay, share. Share button.
Here we go. Perfect.
Better?
Yes.
Thank you.
Thanks,
Which
John.
screen are you seeing? Okay, so you're seeing the one with the big screen? All right,
Yes,
so,
introductions.
all right, yeah, that sounds good. So I'm going to start here because just to level set a little bit. So Steve showed a great example of, the overall, overview of the product set and everything, and really emphasized, how we have a data lifecycle where we sense and then we explore, we act, right? Or sense, understand, and act. And, so now we have a really good understanding from SaaS's point of view what artificial intelligence is, machine learning is, and streaming analytics and some of the challenges around those. What I like to do is maybe take a couple examples of machine learning here and dive into them and show exactly, like I'm going to show a computer vision example, and then I'm going to also show an anomaly detection example. And, so now you'll have more of an understanding of exactly, once you have the SaaS products, exactly how you would go about doing some of these things. Because, frankly, when Steve's talking, it sounds all magical. Good job, Steve. So having said that, our first example is going to be an example where I'm going to get some demographics information from a video. So this is a computer vision example where we're going to use object detection, where object detection is defined as finding objects within an image, and we're going to use then image classification models, which will then so the object detection model will do the face detection, and the image classification models will then do the age, gender, and emotion of the person. Okay, so I got a build slide by accident here. I didn't realize it. So what we're going to show here is streaming analytics, showing real-time streaming, how you develop this. So you're going to take images from a connected camera, feed it into, SaaS's streaming analytics engine, and run these models. And then we also have some other technologies that we can show, like how we integrate with open source, such as Python and OpenCV and Jupyter Notebooks, and I'll show you all that as well. All right, so the first step in this process is creating the actual analytic models. Now, this is an offline analytic development cycle, right? So what you've got to do here is you've got to take giant data sets of images and feed them into a training exercise. And that training exercise will use different types of analytical models, like I said, we mentioned earlier, tiny YOLO models, or VG16 or ResNet. All these types of models are then used to create what we call portable analytics. And in SaaS's terms, this is called an A-store file. And I'm not sure what the acronym actually stands for, but I'm going to call it an analytics storage module. Okay. Steve, you can tell me if that's not right. Is that the right name?
Yep, analytic stores. Yep.
Yeah, analytic stores. So once we have these analytic storage models, we can then deploy those analytic store models into a streaming project, and then do the streaming analytics on real-time data as it comes off the camera. So to reiterate, the first step of the process is to create a collection of data images that you can then train your models with, right? So even though I only have one picture of, or one thing of like an images, right? There's actually going to be, 4 of these, right? So the images that you're going to use to train emotions are going to be, happy people and sad people or whatever, right? And so then the images that you're going to train, male or female, are going to have to be classified into 2 different groups, so male and female, right? And then age, I had to classify the images according to, different age groups. So what I did was I said, is this person between 1 and 5 years old? Is this person between 6 and 11 years old? Something like that. So the images that we're going to use to train the models have to be created and cleansed in a certain way to match the task at hand, I guess is what I'm saying. And so anyway, so that's it. And when you're training these models, it's really helpful to have what we call GPU support, which is basically having a graphics processor on the machine that you're training the models for. It vastly speeds up the deep learning process. And in this example, we're going to use some convolutional neural networks to train these models. Okay, so in one of the things that we are going to show here is we have a machine learning, deep learning Python interface called DLPy. So DL stands for deep learning and Pi is Python, right? So what we got with SAS Viya was a bunch of APIs, right? That then somebody created a Python interface on top of those APIs so that you can interact with SAS Viya through these Python APIs. And then on top of that, somebody created, this DLPy interface, which then we can access through a Jupyter notebook. I know it's a lot of stacks in our Lego tower here, but so in effect, what we're going to show here is a Jupyter notebook that is going to be used to interact with SAS Viya that can then be used to train an analytic model. And this is just, I'm just trying to show underneath the covers, how this actually would happen. Okay, so in this case, this one is the one that's going to train the age from faces. Okay, so if I'm going to go over to the actual thing here in the actual Jupyter notebook here in a second, but I will just go through this table of contents because this is basically what we're going to end up doing. So basically, we're going to set up libraries and launch CAS, and CAS is basically the SAS Viya in-memory database. So then we're going to load all the images into that in-memory database, and then we're going to change those images. Like, so those images coming in might be big or small or whatever. So we're going to, for our modeling purposes, we need them to be an exact size. Like, so we need to resize these images. We might need to shuffle the images. So there's all these tools that allow you to work with the images in the database in an in-memory database in CAS so that it's very fast, right? And so then we're going to set up what we call our model architecture, which is basically setting up our convolutional neural network. And then we have something called fit the image to so once we have our convolutional neural network set up, then we actually do the machine learning part, which is basically feed hundreds and thousands of images to this thing and have the machine learning thing actually work. And then once we have that, we can do some analysis to take a look at. We have some analysis tools in here that you can see how well your machine learning algorithm performed. And then if it didn't perform well, then you make some adjustments to some hyperparameters and you run it again. And then once you have it the way you want it, then you would save the model to an ASTOR file, which we mentioned earlier, and that's what we would then deploy. Now, there would be one of these files for each of the models that we're going to create, and I'm just going to quickly take you through one of them because, once you see one of them, you have the ability to work through the others. So let me go to my web browser. All right, so this is an example of the actual Jupyter notebook. And I'm not going to go through every one of these things, but I just want to point out the highlights so you can actually see a little bit of what's going on here, right? So this SWOT setup is just setting up what I said before, where you're just interacting with the SAS environment. And then we're going to set up some Python libraries that we need to do some analysis. Then we're going to import our deep learning modules that are part of the deep learning product that we're going to use. And then we're going to import the data right? So once we import the data, then we can start looking at it to see what it looks like. Okay, so in this case, you know, we just have some people, and so then I can look at these ages, right? So I've separated the ages from 35 to 44. You know, here's one from 55 to 64. And this was actually a big problem in training this, is we got these images, of course, off the internet, the way everyone gets images. And people, especially women, look a lot younger than they really are. So it's very difficult to pick out ages. I had to go in after the fact and filter some of these things to remove some of these pictures of people that didn't look their age, let's say. So anyway, it's a bit of a challenge. So, but that's the sense part, right? You have to get your data, and then you have to cleanse the data, because if you just grab data, right, and you use it for a machine learning process, if the data isn't correct and it's not tagged correctly, right, then the output images of what you're going to get is not going to score correctly. Okay, so once we have the data and it's separated into these categories, right? So I separated them all these categories like this, right? Then we convert them, you know, to a set size here. So I made them all 416 by 416 pixels, and then I shuffle them just for the fun of it. Anyway, so then I run my, then here's where I'm setting up my convolutional neural network. In my case, I'm using a ResNet 50 cafe model. And this is just an example of what that is. And then here is, you know, you may have heard before what, you know, we need to tune our hyperparameters, right? So these are the actual hyperparameters. So if you run this model and it doesn't do what you want, when you check to see if it's, you know, there's performance metrics after the fact, and it's looking at things incorrectly, you know, you have two choices. You can either change these hyperparameters or go back to your data set and make sure that you don't have like a 70-year-old man's picture in with the 5-year-olds, which I actually had. So that was a bit of a challenge. Okay, so then you can check the results, right? So we have, remember I said before, we have nice, easy ways to check results. And then this is the kind of slope that we want, you know, so when the model first starts, you know, there's a higher level of error. And as you run through the training process, for each one of these runs, the slope should go down to near zero. And then you can go down here and you can check to see how you've done, right? So now, basically what I've done is I've taken a random selection of the pictures, you know, of the tests that I've run, and to see, you know, basically for this picture, my prediction for this person is 91%. So you know, SAS is all about statistics. So what we're doing is we're not saying this person is 34 years old. What we're saying here is that we think there's a 91% probability that this person is between the ages of 35 and 44, and so on and so on. So if you go down through here and you see one that's incorrect, then you can look at it and go, you can make a judgment call of whether you think that, oh, well, that's incorrect because I've got a picture in the wrong place, or it actually is incorrect. So these were an example of what the successful ones would look like, and then down here you can get a sense of what the unsuccessful ones look like. And you can see, like, some of the pictures that I fed this thing were blurry. So when they're blurry, you know, they may not come out correctly. So then you can say, oh, for you know, for pictures that, you know, may not be in focus, you know, maybe that's the problem with my model. So basically what I'm saying is there's techniques here that you can use to understand and how to train and go through an iterative process until you get your model the way you want it. Okay, there's also some other examples of to display a heat map of, you know, where it's actually, you know, how it's defining the layers in your convolutional neural network. And then the last thing is just one line that basically says, I'm going to save this model as an ASTOR file. And that's all that is. Okay, so normally there would be questions at this point, but since we're all on mute, there's no questions. Okay, so It's just the next page. Let me make sure I'm on the right page here. So what we've done here is now we've taken all our sets of images and we've trained those models using that process I just showed you and created these ASOR files. Now, what we're going to do now is we're taking those things and we're going to deploy those models, you know, the convolutional or the object detection and the image classification models onto a streaming analytics engine, is what we call ESP, right? And what's happening in this flow is that, so the first, like the picture could be a very big picture, could be a security camera or whatever, right? So that picture comes in, but our models are only trained on faces. So we need to get the face out of that picture and feed it to the downstream model. So the first step in this process is to do a face detection using a tiny YOLO model, which will detect the face in the image. And then we're going to use Python to crop that face out of the picture. And then we're going to feed it to these 3 different models. And then in the end, we're going to transform the results of those things into an MQTT JSON message. And then we're going to feed it to our little app that I wrote for the phone that can then, you know, show the demographics, right? So you can see my wife, she's very happy that I made her look like she's 25 years old. That's really, really cool. All right, so next, one of the things I want to talk about is our graphical streaming model development environment. You know, in a lot of tools that you might find, open source tools, you'll be coding in Python or R, and it's you know, difficult to say the least. SAS has a great graphical tool that allows, you know, a drag and drop like interface, and so that you can code this whole thing. This whole app is basically done with the boxes that you see here. So the top one here is basically I'm dragging in a source window which will grab the data off the camera using this UVC connector. I mean, that's just the name of the connector that we use to connect to USB connected cameras. And then we're going to resize the images to 416, because you remember the model that I created only, you know, reacted with pixel sizes of 416. And then we're going to feed that model to our first thing, which I showed before was the face detection, in which now, once the face detection happens, we still have the big picture, but now the face detection just draws a bounding box around that picture. So now we're going to feed that bounding box to a Python program, which will then crop the actual face using OpenCV into, you know, a smaller picture, right, which just represents the face. And actually, my gender, I actually do a few things here. My gender detection images were all black and white. So in that case, I converted them to black and white on the fly so that my gender model actually worked a little bit more accurately with that. So anyway, so the thing I want to point out here is that this model is this graphical development tool is a great way to more easily create and manage your models inside of ESP. I ended up with another build slide. So we end up, basically I pointed out all these things. So basically it's a low code environment. You can edit your models, you can upload, you can publish, and then you can test them. All right, so here's a little video of this in action. I think it's running. Maybe I do a play here. All right, so on the left side, this is the actual bounding box that I'm drawing around the face that's detected in the image. And basically I've got a camera sitting on my desk and I'm just putting pictures in front of this camera. And you can see that it's doing 3 things. It's determining the gender. It's saying whether, you know, the age of the person, right? And it's giving an emotional intent, okay? And so anyway, I just have some examples here I'll run through. This is me, you know, obviously. But, you know, so, and then, 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 you know, so, it's also being nice to me. I'm just feeding it some different pictures that I downloaded off the internet just to see how it would do. You can see how you know, this could be used in a security environment or marketing or in a, you know, in a store to understand, you know, the clientele walking past a certain display. Like you have a display that you're trying to sell cosmetics, you'd like to know what age of the people that come by would like to see at that cosmetic counter. Also, you know, in a security environment, it could be something like this as well. The face detection, I just showed an example of face detection can, you know, it can do multiple faces at the same time, right? And, you know, so you could actually be feeding, you know, multiple images to your algorithms. It also only detects human faces. So if I show a picture of my dogs, they don't have any display here. And lastly, I coded it so that if the space is really small, so I have a minimal pixel count, right? So if the picture is very far away and I don't think I'll get a good accurate prediction out of it, I just I wait till the person gets closer, and then once I have a closer view of it, then I can make the prediction. All right. Yeah, that was no. All right, so once you understand, you know, how to do, you know, computer vision, object detection, image classification, the world's your oyster. I mean, we have all kinds of examples out here on our SaaS developer pages. Here's another one I created for manufacturing using image classification, using Rubik's cubes. The whole idea here is I wanted to be able to tell whether the cube was actually solved or unsolved. And you could see how in a manufacturing environment that would be very useful. It's like the wallboard example that Steve showed earlier, right? You just want to understand manufacturing defects, okay? And below here, the one got created to identify social distancing guidelines in the airports. And so you can identify the people and then understand how far they are away and then calculate the distance between those people. These examples are out there with full documentation, and you're welcome to go through them as well. All right, so I want to do a time check because I feel like I'm behind. Carolyn, do I have time to go through another one of these, or should I finish up?
You have 7 minutes left, Tom.
So, Steve, I don't think I have time to go through another one of these. Maybe I can just go through a high level and show the slides.
Yeah, I'd suggest that. Yeah, just to give them a sense of the anomaly detection. Yeah, definitely.
Yeah. So one of the things that's important to note is what we've done a minute ago, well, 20 minutes ago, was we took a bunch of pictures and we gave it, you know, the tagged images, right? And we developed analytic models based on those things, and we deployed them, right? So there's also something called unsupervised learning. And this is where you don't have a set data set, okay? You want to do real-time analytics, but you don't want to have to employ that data scientist to develop analytical models. So you need to develop your analytical models on the fly. And so this is a very cool thing, because, like, say if you've got a factory with 5,000 machines in it, and you need an army of data scientists to develop 5,000 individual models and maintain them and do that whole data lifecycle process on them. So in the case where you can have real-time streaming analytics and you can automatically sense and create machine learning models on the fly from the data as it comes in, is very powerful. Okay, so this is the situation, what we're going to do here. So basically we're going to have some mobile data here, which we're going to send into an MQTT broker. And then I'm not going to go through this, but basically what we're doing here is we're saying We're going to use some anomaly detection algorithms, namely subspace tracking and k-means, and we're going to determine anomalies based on the accelerometer inside of the phone. Okay, I'm skipping that. So this might, all right, so good example here. So basically I've got an app here that is available for download. I'm just going to set up my MQTT broker, and then I'm going to start streaming data in, and the data is going to be, you know, dynamically. So I didn't have a data science create an algorithm, right? All I did was go into ESP. I created those subspace tracking boxes using that drag and drop interface. And then after 30 seconds, you know, that's the window of time that determines, you know, my training exercise for the actual model, that my anomaly detection model that I'm created. So once I have that 30-second window that determines, you know, that my model is set, it's passed down, and then I can dynamically use that to score the images. So I can determine whether if my phone is sitting still, then it would say it's good like it is here, but if I start moving it, then it would say it's an anomaly. So this is a really good example of showing how easy it is to set up anomaly detection using your phone, using a mobile app that's available on the website that I can show you in a minute. Okay, so we also have some other great anomaly detection use cases. There's anomaly detection for floodlights on the SAS campus. So basically, if you have a lot of things, right, in this case lights, they're all doing the exact same thing. They're all generating the same data. It's very easy to do anomaly detection on those things using this type of subspace tracking algorithms. We also have other anomaly detection things, algorithms such as SVDD, which is support vector data description. I'm not a data scientist, so I don't claim to know what that is, but just know that it's out there, right? So anyway, so now here's the call to action for you guys. All the information, everything that I've described to you is out on developer.sas.com. There's examples and, you know, just, you know, GitHub repositories, the mobile app is out there. And we're adding to them all the time. So everything we have is out there. It's a good place to start. You can use that that sample thing, that the test environment that Steve talked about earlier to do and create these things. And yeah, it's a great place to get started.
And many of those examples, Tom, in your IoT analytics lifecycle use cases, many of those samples are already preloaded with example data in the ESP free trial that we were talking about at the beginning. So it gives you a chance to get in there and start playing with some of these things pretty quickly and see some of these techniques.
Yeah, so if you look down through here, all the things I described are here, right? So you can go to each one of these things and you can learn exactly how it's done, because each one of them ties to a GitHub repository that has a complete description and a better video of the example of how to make this all work and get it going.
Perfect. Perfect and perfect timing. Any, Caroline, I don't know if you wanted to see if there were any other questions. I was answering a few questions as we were going, but.
Yeah, thank you so much for answering those questions in line, Steve. If anybody does have any questions, please, we do have a minute left, so I encourage you to put it in the group chat. If not, I'm sure Tom and Steve would love to connect with you afterwards. So please do connect with them via LinkedIn, or if you need help connecting with them, I'm always happy to connect. But thanks again, Steve and Tom. Just wonderful presentation, and thanks as well to the lovely Michelle Knoll for her help setting this up as well.
Of course. Thank you.
Great to have you guys.
Great.
All right, and next up we have Ted Morris from Clario. So we'll let Ted get set up. Thanks again, Steve and Tom. Great presentation.
Well, thanks for having me.
Yeah, good morning, everybody. Ted Morris, just a sound check here. You hear me okay, Caroline?
You sound great. Thanks, Ted.
Okay, great. I'll share my screen then. And how do we look?
Lovely. You might need to make it a little bit larger.
Okay. How's that?
That's great. Thanks, Ted.
Okay. So I'm going to follow on a little bit from the presentation that Steve and Tom just did. Let me introduce myself. I'm Ted Morris. I'm kind of the analytics guy at a small services and consultancy company called Clario. We're based in the Triangle area, not very far away from SAS. We have a significant presence in Europe and also in Australia. And recently we have become a SaaS IoT ecosystem partner, which has been very exciting for us. And I thought for Developer Day, I would share some of our experience as we've started to work with the ESP server and some of the SaaS capabilities around that to really illustrate how our very profoundly open source offerings come together very nicely with SaaS. And I'm trying an experiment here today. Everything is going to be embedded in this notebook. I hope it comes across clearly. Before I get too far into this, I want to thank a bunch of people up front because we couldn't have made it to where we are today without them. Steve's been really instrumental in helping us get this thing rolling and the rest of his team. But two people from SAS on the support side, Carlos and Ravi, have just been terrific helpers. Ravi in particular built some of the containers that we needed to Dockerize the things that we needed to do. And then on the Clario side, our CTO, Bruno, along with Feder, who works with me here in North Carolina. Newman and Kiefer are our SRE team, and they bailed us out yesterday when we had a little problem with some certificates on our side that expired and we had to move fast and get them all running. So thanks to everybody for that. And finally, all you folks at RIoT's been great. So three things, three stories that interweave here really. First of all, hybrid analytics solutions combining open source and SaaS capabilities are possible, powerful, and production quality. And I want to emphasize production quality because that's really one of the things that Steve just hit on very, very clearly. The need not only to build good models, but to be able to deploy them, to monitor them, to govern them, and keep them managed. The second story, and those of you who know me at all, I talk about this a lot when I talk about machine learning. There's a lot more to machine learning, whether it's on streaming data or any other data, than just the mechanics of an algorithm. It's pretty easy to go out and find examples of how an algorithm works and hook it up to data, but there are some things that you need to think about as you select algorithms and as you select a more broadly a general approach. And I want to just hit a few high points there that you can take away. And finally, I really want to talk about the Python environment that SAS has made available so that those of us who are really Jupyter and Python oriented data scientists can really begin to very quickly work with a lot of the SAS capability and bring an application or really a full architecture together fairly quickly. So let's talk about DSH. One of our primary clients is a large telecom in Europe. And we have built for them something called the Data Services Hub. And it has really these 5 very major value points. It's focused on streaming, processing low latency data, and very large low latency data. And Kafka is what we call the beating heart of the whole platform that we've developed. It's a multi-tenant environment. So we basically allow different users to engage with the platform in a highly isolated way so that different tenants don't run into each other. They don't step on each other's toes. And you don't run into things like the noisy neighbor problem when you've got multiple users in that environment. Those tenants are largely self-managed. So we provide management services that allow them to set up their Docker files and deploy them onto the platform and so on. And finally, underlying all this is a scalable messaging interface. We use MQTT for bidirectional external communication. And I want to really emphasize bidirectional, because a lot of the things we do involve streaming data in, processing it, using machine learning models to make some decisions about that data, and then deploying an action directly back out through the network to the device, potentially on the edge. So let's just have a quick look at what DSH looks like. There's really two primary stacks: the core stack and what we call the management stack. And the core stack, as I said, is built around Kafka. We have the things that you need to do to use Kafka. We have a last value store. We have a lot of security wrapped around Kafka so that not just anybody can get at it. And then we have this MQTT adapter protocol, which really provides us the interface to the outside. And we're doing work with environments where there's close to 1 million devices. It's easy to do streaming across 100 devices or 1,000 devices and even 100,000 devices. But as those numbers start to go up, it gets very challenging. And so one of our principal capabilities is ability to connect to many, many devices, bring them into this environment, and then use Kafka, which can handle very large volumes of data, to process that data. The other major piece of this is our tenant environment, which is really based around Docker. It's a containerized set of capabilities that we have added some deployment capabilities to ensure that containers are deployed in a very secure and isolated manner. I won't go into all the details of that, but the notion again being that tenant A can communicate with the outside world via networking, but really the only way tenant A and tenant B in this picture can communicate with one another is over the Kafka topics. And that's really important, because what it means is we can kind of have a co-opetition environment here where two tenants may be competing with each other at some level, but may also be sharing some data with one another. And we can do that by setting the security and authorization around the different topics that are on Kafka, so that only the things that tenant A wants tenant B to see, tenant B can get at. And that's a really critical part of this whole environment. The other part here is really used by our management team to make sure that the system is up and running, to collect metrics, and both on performance as well as consumption for chargeback and that sort of thing. So one of the things that we've run into is that in a number of our client situations, they have adopted DSH or something very like DSH that we have built for them. And at the same time, they are already an established SaaS account. They have deep expertise with SaaS. They've made a long-term investment, both in people as well as the software itself. And the question then becomes, well, how can we bring these two worlds together? How can we intertwine them? How can we leverage our SaaS investment to get real value out of the data that we are streaming across this very powerful streaming data platform? And the answer is ESP. ESP can run in a container in one of our tenants, the server, and ESP then becomes the bridge to all kinds of other SaaS capabilities. As you saw, it's got its own set of algorithms that can be worked with both in real time, so to speak, or very low latency anyway, also in batch. But there are also ways to even build models outside of this whole environment and then import them into the SaaS ESP environment and use them for scoring. So what we've done, and what I want to share with you in the rest of this presentation really, is built a little prototype based on actually one of the demo examples that Tom just talked about, which is the floodlights example from the SAS campus, looking at campus lighting. It's very much analogous to a lighting project we're looking at in Europe on a very much larger scale, where we're going to be looking at managing the street lights for a very large area in Belgium. And those street lights, there's a couple of things we need to be able to do. One is we need to monitor them for anomalies. Are they working properly? And that's what we'll talk about today. But we also need to be able to control them. These lights are all LED and they have controllers. And we have the ability, using incoming data and processing and logic, to turn those lights on and off depending upon environmental conditions, to change the normal dimming schedule that they might have based on weather or based on special events and that sort of thing. So the architectural pattern really is to deploy ESP in a tenant container within our platform. And then what I'll show you today is I'm going to use a device simulator that will be simulating MQTT, sending data into Kafka. Kafka will then, ESP will then subscribe to Kafka and get those messages as they flow, and then we'll do some anomaly detection based on that using the code basically that we got from the demo that we used as a learning tool. Now I'm going to start that little device simulator right now because I want it to get rolling and let the data flow for a few minutes so that by the time we get to processing it, we'll actually have something interesting to look at. So I'm going to go ahead and do that. And it's off and running. So first of all, let's talk a little bit just about, from a programmatic point of view, how do we connect? We've got some preliminaries here, just importing the things that we need. Probably the most important thing for us today is this ESP Pi connector. And we're going to be using the publisher connector. And for those of you who are curious, we're using ESP 6.2. I understand version 7 is going to go production here fairly soon, but I can't tell you any more than that, because I don't know. We just connected to the ESP server. This ESP server is that server that we saw deployed in that tenant container up above. And I'm just going to do a little scaling of the images that we'll see down below so that they fit better on the screen. So this example is outdoor lighting anomaly detection using that algorithm that Tom mentioned called subspace tracking. And I'll talk a little bit more about subspace tracking in a minute because it's kind of an interesting algorithm. I wanted to graphically represent a little bit how all of this works from a kind of a coding model perspective. And so I tried to diagram this out a little bit. Basically, the notion is we've got these core objects. The largest encapsulating object is this ESP project. In our case, we're calling it Anomaly Detection Simple. Inside that, we create something called a continuous query, which should make a lot of sense. We've got a continuous flow of data. So we need to continuously query that flow to get that data into our world so that we can start to process it. And the key way that we do that, and the key way that in many algorithms that we deal with streaming data, we use something called a window. And a window can be time-based. It can be based on the number of readings that we take. And in this case, we'll actually be using the number of readings, and I'll show you how that works in a few minutes. But so we're continually slicing the data into a small chunk that we can process rapidly, but is big enough that we can actually get some useful information out of. And we'll show how that works in a little bit. What happens here is that the Kafka publisher connector is going to connect to our DSH Kafka proxy, which then connects in turn to DSH. And this proxy is here largely as a security mechanism. So let's just do that. We're going to create the project. We get a little graphic here that shows the project container. We're going to create that continuous query and add it to the project. And then we're going to create the source window. And that basically involves creating a schema so that we know what the data look like. And then this little object just sets up some very important security information that ESP needs to have to be able to actually connect to that Kafka proxy. Now, as I said, we're using a Kafka publisher object, and I want to share a little semantic twist that we ran into. The terminology for those of us coming from the outside may be a little confusing. So normally we think of, here I am, I want to subscribe to Kafka. And so my first impulse was to use a Kafka subscription object. But in fact, we're connecting to a Kafka publisher because Kafka is publishing the data to us. And so it's a little bit of a semantic twist, but it's a good thing to remember that when you're connecting to Kafka, you're actually going to be using a Kafka publisher connector. And so we're going to do that right now. And we're going to add that into the source window. And now we can see what the schema looks like coming in. And if I click on this, we'll get an update as to what the Kafka connectors are that are available in our project. So now we've got this mechanism. We've got SAS ESP as an engine that will give us access to great SAS capability, connected to this very large scale, powerful platform that we can flow very large amounts of data over. From this point on, we're really going to need to think about sort of, okay, what are the analytics we want to do? And in this case, we're going to be looking at a specific example of anomaly detection, but I want to take just a little bit of a side tour to talk about some of the things that you want to consider as you think about doing machine learning on streaming IoT data, or streaming data in general, as a matter of fact. As Yogi or Niels Bohr, depending upon your preferences, predictions are hard, especially about the future. And making the decisions about how you're going to make those predictions is really critical, because it can be the difference between something that really is meaningful and makes sense, or something that really is correct mechanically, but may not actually deliver the business value that you want. Overall, we've talked in the past, and Steve did a great setup on some of the basic things you need to think about in batch model building. We need to think about data quality and continuity. We need to think about data preparation. We may need to transform the data. We may need to impute missing values. We may need to create derived values from multiple data elements and combining them into a single data element. Or we may need to take a data element like a date, time, and break it up into pieces so that we can manipulate them more easily. And we may need to enrich that data with another data source, another stream of data from the outside, and bring those together and merge them and create something even more powerful. Certainly in the case of streaming, low latency is really critical, and that means that we need to think about making sure that the model that we build can process data very quickly. We need to think about the type of problem we're going to solve and what data we actually have available. And well, I've got labeled data here, but really it's more broadly what data are available. And we need to think about data dependencies, the data horizon. How far out do we have to look in the data stream to make a reasonable guess at a prediction? And also, how quickly does that data become obsolescent? How soon does it not have any value anymore? And these kinds of considerations lead us to some questions about what kind of algorithms we should use and what sort of approach we should use. And I'll talk more about that in a minute. You know, some of the key challenges that we run into, and Tom touched on some of this in his presentation, really the number one challenge, I think, for streaming is we've got an unbounded data set. Historically, machine learning comes from a place where we bring all the data into memory or into a pageable environment, and we build a model using all the data that we have available. We can't do that with a stream because we don't know how much data is going to be available. So we have to break the problem down. There's a couple of approaches. One is this notion of using windows, or as the mathematicians would say, a subspace. And we'll talk about that notion of a subspace more in a minute. We may collect a set of data over an extended period of time from our stream and then do batch training on that large sample. Or we might use something a little more sophisticated that we call incremental learning. And I'll talk about that in a little bit. You know, we may not have labels. We may not have the benefit of labeled data, meaning we know the outcome of a particular event. So we may have to, you know, limit ourselves to unsupervised learning or something called semi-supervised learning, where we may be able to collect a few instances of labeled data and then really infer from that how we might treat a larger streaming set of data. And of course, the other big challenge in many of these environments is velocity. The data is moving fast, so we need economical algorithms, and we may need to make some decisions about approximation. Some of you may have been in my session a year ago where we talked about data sketches. These are really just aggregations of data, statistical summaries of data done in an approximated way that's very fast. But there are additional implementations and techniques around this that we need to think about as well. So, you know, just touching on the machine learning, you're going to hear terms like unsupervised, semi-supervised, supervised, and incremental. I want to talk just briefly about what those mean. So, unsupervised learning is kind of like, this thing is like those things, or that thing down there in the corner is very different. We don't really necessarily know anything about what those things are, but we make some assumptions about the notion that if they're clustered together, they may, are in terms of the distance between the data elements, and we calculate that using the different descriptors that we have of the data. And the things that are closer together tend to be similar, and the things that are farther apart tend to be different. And sometimes we find things that are out here. And this is a very good example of finding an anomaly. This one just, there's nothing like it, and it's off here in the corner. Supervised learning, on the other hand, is where we you know, say something to the effect of, this thing is a barbecue plate with JoJo potatoes. Maybe that thing over there is a burger with fries. And maybe those things are fried chicken with waffles. Yeah, I know it's before lunch. That's probably a cool example. But the key thing here is with supervised learning, we have to have labeled examples. We know something about the objects in advance, and we're doing a similarity comparison. You know, supervised machine learning basically involves taking that training set, doing the feature engineering, splitting it into pieces, and then training a model and testing it and evaluating it. Once we get it to a point that we're comfortable with it, we can then deploy it in batch. We would just take new data in batch, do the same transforms because the data needs to be the same in terms of its structure and content. And then we apply the model and get some predictions. We can take that same mechanism and we can take that model and deploy it out into an operational world where we just do the scoring one event or one data example at a time. We might write those predictions into a database, and we might also use them directly and deploy them into some operational process so that we can actually do process control, or we can control how behaviors happen on a web page, or not any number of other things. In semi-supervised learning, we can use a small amount of training data that's labeled, build a preliminary model, run an additional set of unlabeled data through that model, and get some predicted label data and merge the two together, the labeled data and the predicted label data, and train a semi-supervised model, which we can then deploy. It's not quite this simple, but this is the general process. And surprisingly, in some applications, this is a very powerful technique. Google's been doing a lot of work with semi-supervised models. And if you're not familiar with it, I've got some references at the end that you might want to go out and dig into. One of the things about semi-supervised learning, and really also about unsupervised learning, is that we have these assumptions. The points that are close to each other are likely to be similar. They share the same label. Data tend to form clusters, and points in the same cluster tend to share the same label. And the data lie on essentially a plane, if you will, of a much lower dimension than the input space, meaning there may be a lot of input data, but we can extrapolate down to a small number of features that describe the data fairly accurately. Now I want to talk a little bit about incremental learning. Incremental learning is getting a lot of press these days. People get real excited about it. There are some really good reasons to do it. One is where maybe training and scoring need to happen on the edge or at a device. For example, because the data is too sensitive. This is really common in health applications. Another really strong driver is lack of connectivity, or maybe we've got severe network limitations. So we can't move the data off the device reliably. And so again, we need to process it locally. Another basic reason is that the data set is simply too large to get in memory, so we need to build a model pieces at a time. And finally, there are cases where a complete retraining and redistribution of a model is either too costly in terms of memory or the time it would take to rebuild the model. And so we want to be able to essentially evolve the model over time as data come in. And this applies both to edge computing and in the cloud. So there are really good reasons to do incremental learning, but there are also some things that you need to consider when you do that. The way incremental learning works is not that different from the kind of training that we just saw. It's just done on a smaller scale, where we'll build at time zero an initial model based on some data that we have. That'll become our default model. Then over time, we train using windows, again, new models, and then we evaluate them and compare them to the models that we already have and decide which one's going to be the best. So in this instance, we're going to train one. Then down the road, we're going to train a new version of the model. We're going to compare it against the one that we already have. And based on those evaluation criteria, in this particular instance, we say, no, this model isn't any better than the one I had. Maybe it's worse. I'm going to keep using that one in production. It's kind of an example of really dynamic champion challenger or competitive training of models. Finally, here we've got another one. We've trained it at time 2. This model we really like, and so we're going to keep it. We're going to discard the old model. So that's just a little bit about incremental learning. Now, one of the things that I've spent most of my career in data science, and it's been over 20 years, is helping people understand that, you know, it seems miraculous, but miracles really don't occur. There's a lot of things that happen under the covers, and there's a lot of knowledge that we bring to bear to ensure that these models are valid and they actually make sense. So what do we need to do to evaluate an approach to make the magic look like magic? There's a few really important things that we need to consider. First of all, do we need to predict a value, or are we simply looking for anomalies? Now, in the case of the example that we're going to get into in a minute here, we're just looking for anomalies. We know that A lighting instrument should have a sort of a steady state set of readings for its voltage. And if that voltage changes too much over a period of time, we know that there's the potential for a problem. In other cases, we may very much need to actually make a prediction. It might be a regression problem where we need to predict a numerical value, or it may be some sort of a classification problem where we want to identify which class a data event, or in the case of images, an image falls into. So if it's prediction, we're pretty much talking about supervised or potentially semi-supervised learning. Anomalies we can handle using unsupervised learning, which to some degree simplifies the problem a bit. Kind of parallel with that, we have to ask ourselves, are we going to have labeled data? Do we have enough labeled data to build a model in sort of traditional classifier methods, or not? And if we don't have enough labeled data, or we have no labeled data, it's going to be pretty difficult to do supervised learning. If we have a small amount of data, labeled data, we can do semi-supervised learning, but then we've got some caveats around that to make sure that we track that and make sure that the model is actually getting us the information we want. Another really important aspect here, and this is, it's highlighted in the streaming environment, but it's actually equally valid even if we're doing batch modeling. And that's the problem of non-stationarity. Is the data changing? Are concepts drifting? Which is to say, is the real world different today than it used to be? This is very common in business. You know, we've got all kinds of different factors, many of which we don't really have a full grasp of. People's behavior changes, something suddenly becomes a vogue, and the way people buy, what they will buy, how much they will pay changes radically. We have to monitor our models, and this is all part of that governance that Steve talked about in the SAS session. We need to watch how the models are reacting, and are the probabilities getting to the point where, you know, we're making predictions, but the probabilities are getting lower and lower, and we're not feeling very comfortable. And also, are we seeing that the distribution of the data as it changes over time is shifting? Because as we build these models, we're making some assumptions about the distribution of the data. And if it's changed, we may have to really rethink how we prepare the data and get it ready to build models again. The other thing is that in many business type problems, and certainly in IoT these days, we're seeing more and more sensors available to measure different aspects of a machine or of an environment. And as new data elements become available, we ideally want to incorporate those into our processing. And so that may mean that we actually need to stop using the model that we have, add additional data elements, and go back and start the training process and the building and deploying process all over again. Time horizon and data obsolescence are a couple things that we really need to think about too. And these are important because it will help us think about whether we need to use incremental learning or some variety of post-processing on a model result. Do we really need to incorporate new data points right away? If we're working in an incremental or in an environment where the data are changing very rapidly, where reality is shifting quickly, we may need to incorporate those new data points into the model as quickly as possible, because the model outcomes will shift as the data shifts. And that's a real good use case for incremental learning. On the other hand, if we have a prediction that needs to just be conditioned by recent history, you know, we can use batch training to create a model, deploy it, and then just use conditional type techniques to essentially temper the output of the model. And a real good example of this is cyclical time series. Weather, actually, as variant as we think the weather is, the reality is that weather doesn't change radically, well, unless you've lived in Denver the last 24 hours. weather doesn't typically change radically from 1 hour to the next. It's a slow transition. And there's seasonality to weather patterns. And so really, we need to be able to condition our predictions in those cases, perhaps with the very most recent readings, but we don't want to necessarily retrain the whole model. We don't need to do that. In the case of data obsolescence, short-lived data, definitely we need to do incremental model building because the data may no longer be relevant. And so we need to shift our window forward and build a new model based on the relevant data. In the case of cyclical time series, again, some older data are more relevant than some more recent data. For example, if I'm comparing March weather to March weather, the year ago data from last year in March is probably more relevant than the data that I have, from August or September or even December. And so that's a case where we want to make sure that the horizon on that data is pretty long, because without that full cycle, we're not getting the most value out of the data that we have. I love this cartoon. I think it's hilariously funny, but it really encapsulates a really important point, and that is you really need to know your domain. This is a classic case of, well, yeah, I can do that with the data, but it doesn't mean anything because life just doesn't work that way. And so I can't overemphasize, and I think I talk about this in every talk I do these days, is we really need to make sure we understand the domain that we're working in. We can't just mechanically apply the models. We need to critically analyze the results we get and ask ourselves, does this result really make sense? And finally, we're going to look at some examples here in the data science environment in the notebook. It's wonderful for exploration, for development, for concept development, and so on, but it is not a good delivery mechanism. The good news is, in the case of working with SAS and the ESP Pi, we can build all of this and we can export it into an XML document that captures all the relevant metadata. We can store that on the ESP server, and we can run it there in a highly controlled environment that's subject to DevOps. And so we have a much more managed production kind of environment. A second thing that I've run into throughout my entire career is that we have to always remember any data that we use in model training has to be available in the production scoring environment with supervised learning. Otherwise, we're comparing apples and oranges, and it's not going to make sense. And finally, we really need to think about whether we're working with pure open source or we're working in a SaaS type environment, about all the relevant parts of model management, versioning models, performance tracking, tracking the data itself, having the ability to quickly roll back a model if we discover there's a problem with it. Can't emphasize this enough, because you're betting your business on it and you want to make sure that you are doing that in a very governed and deliberate way. So that was a little bit of a sidetrack. I want to get back to the code now. Let's talk about subspace tracking for just a second. So what is subspace tracking? Another really handy name for it is moving window PCA. And basically what this means is we're going to use a technique called principal components, which I'll talk about a little bit more in a minute, to take a bunch of highly correlated features and extract from them a set of uncorrelated independent features. And by analyzing the changes in the independent features, we can identify true anomalies or degradation over time, depending upon what our objective is. Some comments about the data. There's really kind of two ways to apply subspace tracking. One is to collect over time multiple observations of a single metric but that metric comes from many similar devices operating under similar conditions. And so in this case, the sensors and the devices will have a high correlation because they're all going to behave about the same most of the time. And that's the case that we're going to talk about here when we look at our lighting example, where we're looking for anomalies in the voltages on these light instruments. But subspace tracking can also be applied in the case of multiple observations of a set of metrics from a single device. The key thing being that in both cases, the metrics themselves, whether a set of parallel metrics from multiple devices or a group of different metrics from a single device, they're all going to tend to be highly correlated. And so to really make sense of what we're looking at, we have to use this principal component technique to extract independent features that are based on the data that we can then use to analyze and determine whether we have a real anomaly or not. In either case, first of all, we need to have a sufficient set of readings that we can really characterize normal behavior. We got to kind of have a baseline. The other thing is the stream of data needs to be continuous and of uniform granularity. If we're having, serious discontinuities, or if we have, if we have breaks in the stream, we might be able to get away with imputation if those breaks are of relatively small granularity. If they're large stretches of time, then we probably won't be able to apply this very effectively. So at the risk of getting maybe a little too technical, but I wanted to talk about this because it's kind of important to understand how this thing works. I want to do a completely non-mathematical discussion around what PCA, or principal components analysis, is. As we said, it's a method that's broadly applied in machine learning. We use it for extracting features and also for dimensionality reduction. And that's a case where we have lots and lots and lots of features about something, and we don't really want to build a model on the whole thing. We want to reduce the number of features because it's computationally less expensive. It's a little easier to manage. It's faster. It takes less memory. All of those things drive us to try to reduce dimensionality. So what it does is it composes component features from the input features. One of the great side effects is it finds the most important features, and depending upon how we configure it, we can drop the lesser important features. And again, now we've reduced that dimensionality. We've got much less data to deal with, and so it's consequently faster. And most importantly, the approach guarantees that the component features are independent. They don't, they're not covariate, they don't vary together. And that's really important for a lot of different kinds of model building, where, particularly in supervised learning, where there is an assumption that those features are independent. In the subspace tracking algorithm, these principal components are going to be calculated over a window. And in our case, we're setting it up to use 240 readings, a window of 240 readings. We do that because, well, it's impossible to use all the streaming data because it's endless. But this also allows us to calculate very rapidly. And because we're using a window, it also has the side effect of debouncing the data. Anybody who works with sensors on a regular basis knows that we often run into this problem of occasionally we get just really flaky readings, and they'll be very transient. And it may happen once or it may happen twice in a short period of time, and then we don't see it ever again. Using windows and selecting the window size carefully helps us to debounce that data, because what we're going to do with the SST algorithm is we're not going to look at changes in each reading, but we're going to look at changes in the aggregate across that window of 240 readings. And in our case, these readings are taken every 5 minutes, so that's a pretty significant stretch of time. Now, we're going to compare windows 5 minutes apart. So each window is going to just shift 5 minutes down the timeline. And so we're comparing things in a relatively short space, but we're using a larger aggregate of information to do those comparisons. Now, when we get into model explicability, if we're just using principal components analysis to create features, particularly in a supervised learning environment, the downside is that the extracted features are a little more difficult to explain because basically they're composites formed from the input features and they're combined mathematically in well-proven ways. But for our purposes here, it's a really, really effective way of doing things. So let's go back to our visual. I think we're doing good on time. So we basically created the project. We created the continuous query. We set up the source window, which is collecting now floodlights data, which over here we can see are still streaming. And now we need to create the actual calculation and attach it to an output file. Now this output file really is representative of many things. That could be a process. We could write individual rows out to some other process, to another service that would do something with that data immediately. For example, automatically schedule maintenance on a lighting instrument that we see that is failing. But in our case, we're going to keep it real simple and just write it out to a CSV file, which we can then visualize. So here's where we do the real work. We're going to create a calculation window. And in that calculation window is this SST model. We give it a schema showing both the incoming data and the outgoing data. We set the window length, which, as I said, is 240 readings. Overlap is -1, meaning we're going to just overlap by 1 reading. The rest of these features I'm not going to get into. It gets a little too mathematical, but the key thing is that we're keeping basically 2 principal components. We explicitly declare the inputs, and then we explicitly declare the outputs. And so with that, we've now created this window that contains the model. This is just a little bit of ledger domain to set up the path so that we can actually, from this notebook, write to the output file that I need. Now I'm going to add the connector for the calculate window that will allow me then to write to that output file. But to do that, I actually need to connect the source window to the calculation window, so we've actually got data flowing through. And we're going to do that with this 1 line of code. We're going to add a target to source, and that target is calc. And the role of it is data flowing. And finally, we can kind of visualize our whole project actually right within ESP-Pi. And you can see that it creates a diagram very similar to the one that I've been working with all along. Here's the incoming floodlights data. Here's the data connection over to the calculation window. And there's the schema in the calculation window. Finally, we can take this whole bundle, which is the project, and we can write it out to an XML file, which the ESP server knows how to work with. And so we'll do that. And finally, now that we've got a project, we need to load that project into the server, and then we need to start it so that the actual flow of data happens. And what's happening here is ESP has connected as a subscriber to our Kafka instance where the data from our MQTT simulator has been flowing for a while now. And then that data will be processed through this window on the ESP server and will be written to the output file. So I'm going to load the project, and I'm going to start the project. And now, like everybody in good live theater, I'm going to hold my breath and hope that everything runs. Just to show you our window names here, we can actually get those from the ESP project. Let's see if the data is flowing properly. A really nice feature of this Python library is that I can get the window and I can actually subscribe directly to the window, and I can use that to create a line, a dynamic line chart. So we'll do that here. And voila, there we are. We see data are flowing. Oh, there's a little dip. And now we've just gone into a period of daylight when the lights are all turned off. We'll see that come back on in a minute here. But meanwhile, I can also subscribe to the analysis window as a test. And that's going to take a minute because I need to collect those 240 readings. So we're just going to let that run a little bit. And while we do that, I want to, for you, those of you who might be Panda geeks out there, Pandas geeks and use Python a lot, it's really cool. These windows behave exactly like a Pandas data frame. And in fact, underlying, they have a data frame structure. So I can do things like describe the data frame. Show me how many instances I have. I'm up to 121 on the data window. I can see the max values. I can see the standard deviation, the mean, and so on. I can also access it just like the analysis window, like a data frame. Now in this case, we haven't quite gotten it filled yet. We're still waiting for it to fill up. There we go. Now we're starting to get some analysis because we've got enough of a window that we can start comparing windows, that overlap that we talked about. So if I go down here, I can start to see the rows that are being created there. Now, kind of to wrap this up, we're kind of running toward the end here. Another approach that we can do is we can actually use some of the visuals capability that's built into the ESP library. And we can use, we can create similar time series charts, but we're going to use widgets to basically display them in parallel here. And this first thing here is going to be a mess because the window wasn't big enough and it's just creating some very strange results. But we'll start to see that straighten out in just a minute here. And I'm going to zoom back out of this just a little bit so that you can see them together, I hope. Right now we can see that the data stream has quiesced again. We're going back into a daytime period. And all of the angle change, of course, goes flat because nothing's changing because nothing has happened. We can wait a minute here and that'll kick back in as we reach a new period where it gets dark and the lights come back on. Or maybe not. All right. So let's move on. I'll give you a static image of a section that I caught earlier, where we can see the angle change here being very pronounced, and it aligns pretty well with the dip in voltage here on this light up here. We can see it again here a few times. What we're basically seeing here is that this light is starting to degrade and there's a problem. So that's kind of my demo and my walkthrough of a very simple example, but with a tremendous architecture underneath it, basically leveraging a very large, scalable Kafka open source foundation, using ESP as our gateway into the rich world of SaaS resources. And hopefully along the way, we've had a little bit of conversation about some things you might want to consider as you start thinking about building models on your own data. I'll just show this here. I'm not going to go through it, but as I always like to do, I've listed a set of resources The SAS guys mentioned it. I've got them here, links as well. And also some open source libraries that you might want to look at if you're into that. And some general articles on some of these topics that might further the depth of that discussion around streaming data, incremental learning, and principal components. Caroline, do you have any questions?
Hey, Ted, yes. One question here. Once a model has been generated, in parentheses, supervised learning, is there a way of seeing which characteristics the training algorithm has converged on as most important?
Yeah, that depends on the model type. But yes, very often one of the sort of the testing metrics that you can use is a means of determining which factors are most important in the outcome. And it varies from model type to model type. I know I've worked with decision trees in the past where it's very easy graphically to start to see which are the primary determinants, if you will, and which are not. But it does vary from model type to model type how you get that. But yes, that is definitely something. And maybe just anecdotally, I'll say that in a project I worked on a few years ago, that was a really valuable feature because it helped us working with some doctors to identify a couple of potential symptoms that they hadn't really been thinking about that, oh, look, there it is, it's in the data.
Thanks, Ted. One question here. Will you make your Jupyter notebook available to today's attendees?
The foundation notebook is actually out on the SAS site. This is actually the floodlights example that's on the SAS site. I can make this available, but you won't be able to run it because of the security restrictions. We're not going to let you add our DSH. I'm sorry. That's a live platform. We really can't do that. But I'd be happy to do that. Yeah.
Great, thanks, Ted. Those are all the questions I'm seeing. If you have a question, please feel free to put it in the chat box. We do have a couple of minutes before Fabio from Tago.io gets started. I do want to say, if you enjoyed this presentation, I encourage you, Clario will be hosting a virtual Lunch and Learn session on Wednesday, October 7th. So stay tuned for more information coming soon on that event.
Well, I'll just wrap up then by saying many thanks to the SAS guys, Steve and Tom. Appreciate all your support in this. You know, anything that's good and right about this probably came from all those people I acknowledged up front. Any mistakes are mine. But it's really fun to do these kind of things, and I'd like to ask, you know, the general audience if there are particular topics that you'd like to hear about in the future. Let us know, because we love doing these events. And we want to make sure that what we're doing is interesting and relevant to you. So thanks all.
Thanks so much, Ted. We appreciate your time. Love the demos, really great. Up next, we have Fabio Rosa from Tago.io. After Fabio's presentation will be the networking half hour, which is brought to you by Dual Boot Partners. So we will be giving away our prize for the day, which is a water-resistant anti-theft smart travel backpack. Thanks again to Tina and Dual Boot Partners for that wonderful prize. So Fabio, if you should be able to share your screen now and we can get started. Thanks so much.
Yeah, great. Just a second, let me set up everything here. I hope you guys can see me here well.
Looks great, Fabio.
Yeah, good. So is the voice okay?
Looks great. Thanks so much.
Good. Let me put in the presentation mode and wait a little bit, a couple of seconds. Okay.
Fabio, we are seeing a little bit of that screen split as before. You might want to move the bar. Yep, there we go. Perfect. Thank you.
Yeah, I have to move the things around here with this Zoom, but so I hope that's not perfect. Okay, Good. So ready to start?
We're good. Thank you so
Okay,
much.
good. Thank you. So I'm Fabrosa. I'm the co-founder and CEO of Tago.io. Tago.io is a company, a software company located here in Raleigh Centennial Campus, NC State. Today we're going to talk about how to get smart, deploy, and deliver IoT faster. Of course, I'm going to talk here also a little bit about the algorithm, a little bit about machine learning, but it's really more about how to deploy the solution with IoT, with different sensors, and so on. One thing that I would like to ask is feel free to make a question using the chat at any time. I'm going to be answering the questions at the end. I think it's better, but please feel free to make any question, and then we're going to cover at the end of the presentation. Okay, so very quickly about us, so who you are, where you are. So first, what we did was we create a platform for IoT to make it easier for developers to deploy their solution. And we did that with collaboration with a lot of partners, so that today we have a little bit more than 5,000 developers in more than 100 countries using Tago.io. So I'm very excited about that. Also, there are more than 1,000 applications with IoT based on Tago. The reality that we rarely do the application by ourselves. We really enable and inspire the customers and the leads, students, developers around the globe to design the application by themselves. So that's basically our work. So if you get the whole ecosystem, we are really more in the software side. But here you're going to see that I'm going to talk about a little bit about the sensor, a little bit about connectivity, because that's important part in our ecosystem. So at the end, what you deliver is really a cloud platform that's helping transform the way the business create value from the sensors and also from the interaction with the users. Yeah. I'm going to divide my presentation here basically in three parts. First one, talk a little bit about the problem. So what's really the problem and the challenge when you talk about get the solution out there. And then also going to talk about some cases that will help customers to give a context. And then the last 20 minutes roughly, I want to get the tools that presented at Tago.io and present to you how to get a solution and scale to add more users and share with others and so on. So I hope that really can bring a very good insights to everyone here. Okay, so that's a lot about what we believe, that we need to simplify to succeed with IoT applications. Okay, when you see, for example, a picture like that, you have a camera that is detecting using AI, can detect that there is an item there that maybe is not safe, so that can send a notification for the security to do something. We think about how to make this work and how to make the business model to work well, right? So there are a lot of options to get this done, and I'm going to talk a little bit about them. But the first thing that we notice work with thousands of partners that use our platform is that normally there are challenges between alignment between the two big areas in the company, the tech side and the business side. So it's very important, of course, for us and for our customers, for anyone that's involved in the IT project to get the requirement very clear, make sure that they understand what the budget that they need for the project, how much time they need for the project. And at the same time, of course, they need to understand this from the business side, right? How they are going to make money or where they're going to save money to pay for this project. So alignment between both areas is extremely important. And the other thing that you notice here during the presentation that you talk a lot at Tago, and every time you have opportunity to talk to the customer, is really about how to help companies to go very fast. What you say, really make sure that we can design the company or the application around speed and integration. That's the two words that you use a lot here. if you do some application that's going to take like years to bring the marketplace, maybe it's too late, right? So how you do things faster and how you integrate your system with other web services. There are great presentation today, talk about other services around for machine learning, AI, database, data available. So every time you put something around IoT, it's important to make clear that integration is a very important part. The other thing that there are sometimes, of course, a lot of discussion around is like, hey, should be this in the edge, on the cloud? So that's important conversation. And we note that there are for sure some new projects coming more to the edge. It's like everything was isolated and went to the cloud, and now we see a trend going back to the device. So that part in our view is really important to make the decision. And I'm also going to talk about that. And the last part that we analyze when we study companies and help companies is about focus. And focus for our customers is translating, doing things that they are really good at, right? There are a lot of conversational questions when companies talk to us, say, hey, what's the difference between you and IBM infrastructure or AWS infrastructure, right? And the things really normally relate to what they need, right? Do they need to build their platform from the beginning, or they can use a platform like ours? So it's really depend on where they want to put their focus, where they want to invest their resources. Should they be spending millions of dollars building everything that maybe is already ready here, ready to go, or maybe they have it to because they really want to go ahead of the game all the time. They're going to continuously invest in growing this team and keep people engaged and do something that nobody else is doing so far. So that's important to make sure that companies can simplify the things. And I really talk a lot about simplification. Of course, it's hard because all the time I talk about very complex things, but at the end of the day, the interface, talk with people in the companies really need to focus on the simplification, not to get that too complex. So some other part of information that I think is important when you think about, okay, how you build this, how you scale your solution, is have a little bit of data here related to the success rate of a project. And give you at least one of surveys, and there are some of them out there. Depending how you see, you can change a little bit the numbers, but basically I think this represents pretty well. This is from Cisco from 2017. They surveyed more than 1,800 companies in the US, UK, and India. And the number that they got in terms of rate of projects in the side of the companies that were deployed with success was only 26%. Okay, so it's really simple like that, like 74% failed. Okay, of course, you can understand what fail means here, but normally you go to the basic of project management. You talk about to have the project delivered inside the cost, the quality, and the time. Of course, there are a little bit more than that when you build something new. But basically, what's important here is also go back to understand a little bit why the project, the perspective of this project that's success. For example, from this 26% of the project, when they interview the two teams, the IT executives and the business executive, they got different response. Only 1/3 of them in the IT team really consider to have a strong success. When they went to the business team, that number was lower. Okay, so that really means that the number of or the definition what a success in the IoT project is really can be vague sometimes. And that, again, that show one of the big problem, right? So why the project fail many times is because of the lack of alignment between the technical side and the business side. So there is other survey from Microsoft last year and McKinsey as well from this year that showed very interesting things or reason explain why projects fail. And there are some things that have really surprised, at least for me, being in this business for many, many years. In the top of the list, is complexity and technical challenge. This is what most of people said about that. And I'm going to show in the next slide the ecosystem, the key components, and how you can mitigate these issues. But basically, that's make a lot of sense because it's new, right? If you see this number, like 74% of projects for IoT fail, you compare with the typical IT project, for sure this is higher, but still there are a big number of IT projects that are in the field for many, many years, and they still fail when you combine everything and try to be very clear about what succeed, what fail. Other reason is related to the integration of the IoT solutions with the company workflow. And that for me, if people ask me what's the main reason project fail, I would say that's the big one. Because normally when people looking for the IoT, they really want to do something new. They are really going to impact the corporation or the users, the partners, the stakeholders. So if they do something different there, they need to expect that. How people are going to accept that, how people are going to use and follow the process, it really impact the success of the project. And the last, not the last, but the third point here on top of the list is really no clear business case. We talk with hundreds of prospects and developers through the month, and we normally can understand or try to anticipate the success of the project, really try to understand how solid they are in terms of business case. Okay, if they want to do something just basic and have just a nice dashboard because that is something what their competitors are doing, we believe that they cannot succeed. We may be wrong, but that's an indication. So have a clear business case is very important. Again, the reason I say that is because I not only think about the concept, not only think about to prove that it works or do what people used to call many years ago or some years ago, the proof of a concept that now is really minimizing this term at least because a lot of things is going to work. But we don't know if the company will be able to make money. So the business case is really the key here. So this diagram here shows a little bit the complexity of the IoT ecosystem. It's not new for many people here, but I think it's good to put in perspective, try to understand that it's very important to work in the interface. Normally I say that if the project is going to fail, it's because of the interface. It's not because our platform doesn't work or the hardware doesn't work or the connectivity from big telecom company doesn't work. Normally it's because something goes wrong in the interfaces. You can see where we are positioned or any other platform. Of course, I talk about our platform here, but there are others that go very close in this location here that's more close to the business. So from the left side, you have the end node or the end device. Normally are the sensors or actuators. So they're responsible to collect information, send it to something in the middle before go to the internet. Normally can be like going to a gateway or a router. Then it goes to the network. If you use the traditional cellular, you will be going through T-Mobile, AT&T, Verizon, Orange, depends on where you are in the globe. If you use the new technology, new network, you may want to use a lot of one technology. And there are a lot of providers you can see here in the middle. There are a big list of providers that we already interface with them to make the work simpler and reduce the risk, or like Sigfox as well. Or you can also connect the device using Bluetooth, Wi-Fi, or any other means of connectivity. And these data come to the platform. Okay, so normally when people talk about this application enablement platform, that's where you are. So it's not only the infrastructure, but there are really components, the models that make it easier for users, developers to build application. That's normally what you refer to. And then on the right side here, you have the integration with the business. Normally that's the side of the integration with the business. Rarely a company come to us or try to do something without connect anything to their own business. They may connect this to their ERP system or CIM because they want to get a notification. They want to get this data processed and sent directly to the day by day. So they don't want to train people. And that makes a lot of sense. So interface integration is extremely important. Then, of course, you have this platform, in this case, our platform, being used by developers, but also by end users. But we have a white label version, so make it easier. So it's very important to say that, because when developers try to do something, they need to do all this exercise, and there are a lot of things behind, very complex, but the end users will need something simple. So we offer this simple, what we call the white label version, with the label run. Okay, this is a typical platform components. So that's why I'm saying complexity is really one of the main reason Project IoT can fail. So that's why important for people to continue to learn about the ecosystem and so on. We cluster in 6 elements. There are more, but I think that's covered in a high level pretty well. One thing that these platforms must have is device management, right? And I showed before. So we, for example, we have a connector for today more than 300 sensors. I mean, 300 different type of sensors. If you want a sensor for water detector, if you want to count people, check if there is somebody on the seat on a chair, CO2, and so on. There are hundreds of sensors already connected and ready to go. They are certified. And from there, of course, you can manage the data, make sure everything is working, get its status, and so on. So that's the first thing. Then you have the data storage. It may be located in the cloud or on-premise. I think at the beginning was a lot about to be in the cloud, but now, at least I personally see more things going more on-premise as well. At least the data, maybe not everything, but at least the data is important. Also because basically no platform is going to deliver everything that you want. Okay, there is, again, the need for integration. So if the data is in your hand, you may take advantage and do some post-process, create some analytics on top of that using your tool. Then you have the analysis in real time. This block, of course, is extremely important to make sure that everything can be processed and that can be very responsive and send the notifications, alerts, and also control your device in real time. What's important here is really to make sure that the tool is really give you the capability to build by yourself, not just simple things, but really more complex. Data visualization, of course, is important, also mobile app. Then the other model is about the user and the access management. This is the key things that I'm going to talk later today, because when you scale, I think some tools are really not ready for that because they focus more on the concept phase. What's okay, they're very powerful there, but getting your product to at least a couple of few customers and thousands or hundreds of thousands like we have, it's really important to have very good access management tool. And the other things really, it's going to be very helpful if this tool deliver option with a white label to brand with your own brand. Before going to some cases, I have 2 cases to share with you here. I'd like to share this very simple chart here that try to explain, giving our experience, what kind of approach for IoT really generate more value. So on the y-axis, we have 2 axes here. One is the relative number of applications in green, and the red one in the right is the value that is generated for the company, the ROI, return of investment. On the X, we have here some options, 5 options that if I would cluster them, that's normally very high level. That's what normally customer go, the direction they go, from the least mature application to the most mature. Okay, for example, if you get the solution number 1, that was a lot about like machine to machine in the past, where was just a simple connectivity. So a lot of applications already in the field still relate to this first concept. It's really more about the approach to simply get the data and sit the data somewhere, maybe to use in the future. Then the approach number 2 is more like, okay, are gonna get the data, but also gonna provide dashboards for our customers so they can visualize things in real time, so they can see what's going on, they can get the key indicators. That's also generate, of course, more value than just bring the data to you and give this to the engineers. It really is more about provide dashboards for your users. And then the third one is when you start to add intelligence. Start to add analytics, can be a mathematical model behind, can be some logic, very simple but very effective, or it can be something like machine learning or AI. Okay, so that's, of course, as we expect to generate more value. Okay, and then we have a process automation that for our view is like one step further. It's like, okay, you process that, and now you are making a decision in real time, and you are taking the actions sometimes even before you notify your user. Okay, if you can do that, if it's safe, secure, that's bring a lot of value. Okay, for example, you can create an action that based on your algorithm is going to generate a ticket for the support team so that they can check what's going on with the system, with the, let's say, the equipment, or maybe generate a opportunity sale ticket for the sales team to call this customer, because based on information that you process, they can offer a new product for your customer. Okay, so this number, the bar you can see here, is reducing. There are not many applications. I think that's growing. I think most of the companies are really trying to go in this direction now. Okay, it is growing. And then you have the fog computing, you have more options. Of course, the fog is not like the cloud, or the edge is like a distributed solution, communicate with several edges at the same time. Why the return in our view is smaller, just because it's something new, normally demand more investment. People still don't get how to do that, so they can do it. They're start to build this, but I think the value here is much more when at least you can have a nice presentation, analyze the data, and take actions. So when you talk with your customer, that's normally what you tell them. So go ahead and build your solution, but try to automate as much as you can. Let me talk about the algorithms that really can bring more value by expanding the capability of sensors. I put here two examples that I see being treated from different perspectives, but basically with the same objective. Okay, when to talk about get smart, bring a smart algorithm, try to reduce the cost of the equipment. That's very important, right? We are saying that the sensors today are costing below $1, a few cents. That's true. However, there is a capability that's needed, and it's needed to process this data. Let's talk about the first one. For example, there is an electric motor that we are measuring somehow with electronic board, and you extract information. Okay, and we are controlling this electric motor. We call these sensorless motor control. It's not really sensorless because there are sensors, but it's very inexpensive. For example, if it's a 3-phase motor, you may have just 3 shunt currents. So you're measuring 3 currents, very inexpensive. You just measure the current, like with a simple AD converter, and this go to the processor. The processor that should be very close to the motor, because decision really should be taken microseconds, really need to have some intelligence, some observer, some control system. But based on that, based on the software that is embedded, or somehow you can say on the edge when that's connected to the internet, is able to extract a lot of information like power, torque, energy, even the speed. Even without a speed sensor, you can estimate the speed very precisely, or the position of the shaft, or even the temperature of the coins. You can do that. So that's why it's so important really understand the physics behind here. It's a very good way, again, to try to align business with the technical team, right? Business wants something cheaper and of course robust, and this can be a very good solution. So have the intelligence in in the edge here make a lot of sense. Other case is very simple, very high level. For example, talk about the vision system. You to have a camera, and this camera is getting the sensors information. And normally up to now, of course, this is moving to the edge, right? It's moving to the online as the processors are getting more powerful and cheaper than before. There are a lot of capability that now you can do locally on the edge. But up to some time ago, I remember a couple of years ago, a lot of APIs to do an image process that now probably they are just to do something very specific that should be done on the cloud. Otherwise, you try to do this locally. But that's the same idea, right? You get the pixels information, you process with a very sophisticated algorithm. There are a lot of libraries nowadays that from there you can get the shape, the size of the things that you are seeing. Count people, recognize faces, get the directions, the speed, try to get quality for quality monitoring system. Of course, industrial application, that's very hot topic from many years ago, not only from now, and even get suspicious activity. So you can combine this information with others. But the point here is that you may have very simple, very inexpensive sensor, and you can extract a lot of information. If that's gonna be located in the edge, on the edge, or in the cloud, it really depends what you are trying to do and what resources you have. Let me talk about two examples that I think is relevant because that really I hope bring some insights for you. We have a customer here in the US that really need to have a solution to optimize their asset utilization. And basically they manufacture pallets for transportation for the box. And they want to optimize because they had no idea where the pallets were at a certain time. What is the time spent in one location, on the other location during the transportation. They tried to use different technologies, but at the end of the day, they really need a very low cost solution where this sensor should cost no more than $10, okay? Also with low capex, so I mean really low investment. They don't want to put a lot of antennas, a lot of the doors, things like that, because that's going to be very expensive. Or try to change the trucks and so on. And the other thing, they really wanted very low operational cost. So it's like added the sensor there and forget about it. Don't ask people to do a lot of things. So the battery life, if you had some electronics there, it's not like just a label phone or RFID. It should be really very low consumption so that the battery could last many years. So if you want to know where this pallet is located at a certain time, basically we could say, hey, what about the GPS? In this case, so you can have a precise information. Yeah, that's true. And it's really not that hard to do that. But first, you're gonna work just outdoor, not indoor. At least can have some, or you have for sure some limitations to work indoor. And it's not gonna be cheap. GPS models cost easily more than $10, $15, just the GPS, and battery consumption is very high. And then depending how you locate on the pallet, it can generate some challenges. So the idea is, okay, let's try to get this location not so precisely. We don't need like a 1 meter, 10 meter. At least we need to know where the pallet is, because the challenge was really try to understand if the pallet was located in warehouse 1 or in the manufacturing line or distribution center. So that's didn't seem hard problem to solve. So part of the solution here was really try to understand, okay, can you use something very inexpensive where we don't have the information like the coordinates from the satellite, but you have like a good enough accuracy. And talk about maybe 20, 50 meters. Is that enough? And for them, that was enough, okay? So it's a combination, the solution here was a combination of using some algorithm, very simple, by the way, from one side, try to improve the accuracy. So for example, if you want to understand if one device is on location close to the antenna, you can maybe just measure the signal strength, okay? You can have a reference, that's good, but this can generate some problems in the real world. For example, if there is a wall in the middle or a window, it can decay the signal strength and give you the wrong indication. But that frankly was one of the things that they tried because it's very inexpensive. But also they can use algorithms with a time difference, very precise information coming from the antenna, going to a cloud system, and the cloud system did the computation. So the hardware itself was very inexpensive, below $10, very small, very robust, very low cost, using LoRa technology. So we did a partnership with a hardware company here in the US to build the sensor. And that's to get the good enough information from the location, okay? And then on top of that, we're able to start to do some analytics, like how many assets is in this place, how long it stay put in a location, what is called the dwell time, how many hours were there, and generated alerts for that if there is something that didn't move for a while. Also, how many assets arrived today, how many left, and then we are able to provide information in details. But more importantly, they start to receive notifications about situations where they want to avoid. For example, if the transportation should come from point A to point B, didn't arrive at point B, something's wrong. So they didn't want to get this all the time. They had no time to go to the system all the time. They just got the key alerts for their system. Other example is about get prediction when to refuel a propane tank. Okay, that's something that was interesting to use machine learning model. Very simple for commercial application, where think about the case where you have the tanks and these tanks for, let's say, commercial application like a restaurant. I think that's what the conversation that time, like restaurants. So they want to estimate when was the best time to go out and refill the certain tanks. So they already had the sensors measuring this, let's say, every hour. That's normally more than enough. So they don't need to spend a lot of battery, a lot of data. And then they'd like to estimate the next, let's say, 48 hours, how this looks like in the future, given not only the current value of the level inside of the tanks, but also giving some situation, some factors that are going to show in the next slide. Okay, so they did really try to predict the best way. And also important here to try to use the same sensor, not add more and more sensors. So cost is very important. So the one way here that was done by the developer was basically using this case AWS. So Tago was able to interface because inside of Tago we have the analysis session, and this analysis allow you to add a code. It can be a code in JavaScript or Python, or frankly any other language. In this case is JavaScript. And the model was creating the AWS machine learning so that we had to basically do the integration using Tago capability that is basically getting the data easily from the sensor, pre-process this data, send it to the AWS machine learning model that was there with some inputs, and make sure that it would be easy to evolve. And by evolve, I mean really start to add some inputs and refine this model and so on, and easy also to maintain and be ready also to scale this model. So that's one example here of the, let's say the dashboard. Again, that's for development. That's not something that you show to the user at the end of the day. But basically, the model here got 4 inputs. One is automatically sent by the sensor, like the gray one, the cylinder. In the middle, presents the real value. Let's say in this case, 50%. So get this input automatically, and then get the weather forecast. Also, you can get this from the web service, like the weather channel or other from the government for free. Try to estimate the temperature in the next day for 8 hours, or the average of them. Try to identify all the factors. For example, during discussion, one of the factors was like, hey, is this like the weekend? Of course, here you can see this being doing manually because that's the concept. But at the end of the day, of course, you know when this, if it's a weekend or not, because during the weekend you have a more peak in the restaurant, things like that. Also, if there is holiday. So the point is, with these factors, it was able to get in the input interface with AWS Machine Learning, so that the level could be predicted. In this case, for example, by running this prediction, you can see that in 48 hours, the prediction was about 31%. So what is considered still green is not like you need to go there and refuel right away. And then, of course, that's the analysis, that's the dashboard, that's important. But then you have this here, the notification for CRM system that sends it to the sales team and say, hey, there is opportunity to go and refuel. Okay, so you have this case, you can build the solution, but how you scale, right? So the second part here of the presentation is really to give a flavor about how you can scale with the tool, so you can generate better or higher profit for the company, reduce the risk. So there are basically 3 steps, high level. First is build the one, right? You build your application, you use it, Tago.io, you build the one dashboard, connect your sensor, then you add the tags and create the policies. For example, you say, okay, this solution, let's say this map in North Carolina with all the tanks, you're going to be presented to the supervisor, but those in Raleigh is just for a distributor specific. So you define the policy, who you're going to see what, and then you deploy. Basically, there are 2 ways to do that. The first one you build, then you can click, I'll show you in 1 second, you can click and you share your application. That's manually done. It's good when you have 1, 2, 3, or people collaborate with you, is this. But then when you want to deploy for your end users, you cannot simply go there one by one if you have a lot of them. So you can automate, and you want to deploy using the run model or UN model. So there are just 2 concepts before I go to the demo. The first one is the tags. So you see here, that's the screen from our list of devices. So there are information like the name, when the device sent the data, received the data, when it was created. Then you see under the red box here, there are some custom tags. You can add things like customer. You can put, okay, this sensor is from company A, company B, then you have the state and the city. You know, you can add the tags the way you want. You can put the name of the customer, serial number, and so on. So you can do this to organize and automate your applications. You can do this for the devices. If you have 1 or 1,000, you can do the same way. You can group them. You can do this for the dashboards, for the analytics in database. Okay, so for example, we have user management. Then you have these 4 users on the top. Okay, so one you give it the tag green, the other blue. Then the dashboards, you have 2 dashboards. Remember, I told you, for example, you wanted to show one dashboard that you show the whole North Carolina state, and the other one just a specific city. So you can say, okay, the green one will be connected to dashboard green, and the 2 other guys, you'll be able to see the dashboard blue. So you just need to connect them using the access management. These 2 I'll show you is where you can create rules or the policies, and then basically you're gonna do what I just said. You say, okay, this is for supervisor, and this is dashboard for supervisor, and this is for the end users, and these are the dashboards for the end users. When you do that, new customers are gonna join your system. They automatically are gonna be assigned for the new dashboards. Okay, so now I'm gonna show you one example. In this case, I use a weather station here as an example, showing in 10 minutes how this is done, okay? Let me switch the screen here. Okay. Okay. So I hope you are seeing right now our browser. So that is our tool, Tago.io. If you go to tago.io, you can subscribe. By the way, we have opportunity for anyone to build dashboards for free forever. I can build up to 5 dashboards and I've added up to 5 devices. Okay, let's say that the first thing you want to build a dashboard. Okay, so there are other tools you can build that, but let's say you build it here. Okay, so here you build. There is this option here. You have a lot of widgets. For example, here a dial, a chart, clock, and bar, and so on. So you build that the way you want. You can change the colors here on the top, the name. There are a lot of features you can do to make this a nice dashboard. Okay, so how this information is getting here is because we have a list of devices. Remember I mentioned that you have a big list. For example, guess for machine Q is a lot of one service from Comcast company, our partner. They have a lot of devices connected. Yeah, this is really different type of devices. Of course, you have hundreds of thousands of devices, but this is here just indicate different types of device for a lot of things that you can imagine. Okay, so these devices are here, and you just pick one device, give authorization in your network provider, and the information basically come here. I'm not going to show how to build the dashboard itself. The goal is really more about how to scale. But you can see, yeah, I forgot. So you can see there are some tags I mentioned before. So this is the list of devices. So I'm saying that these, all these devices are with a type called customer. And I also have an intern ID. So each customer has an intern ID. It's up to you what you're going to do, but basically that's one way to do things. And then you can also have the list of user. So each user that's joined your system that I'm going to show you in 1 minute, also going to have the same tags. In this case, you associated new devices with the new dashboards. Okay. Here you have the policies. After you build your dashboard and you connect your devices, initially you can start manually. Later you can get a spreadsheet with 100 devices, 1,000 devices, and upload all of them at the same time. That's one way to go, but we always say start here manually at the beginning. But everything using the same tool. You don't need to switch tools for that. You can get here, for example, dash to users. So basically here what you're doing is we are defining a policy with 2 basic information. Target, who is the target? Who's going to receive that? It will be all the users. We call run users because it's like, it's not our customers, it's your customer, because we are going to deploy this solution I'm going to show you. And then you define the tags. So all users type customer, we receive these dashboards. You will receive a dashboard here. That's the dashboard that I show you. And also another dashboard to add weather station. Because in this case, we're showing like a weather temperature, weather information coming from sensors in the field. Okay. So you'll have this here. And then you can deploy a solution. When you deploy a solution, you can use this model here called run. This model is very interesting because you can get your own domain. For example, here I'm calling weather.run.tago.io, but we can eliminate this tago.io completely. You can have like a weather.mycompany.com, for example. Okay, I can change the domain, as I mentioned before, the bar, the colors, the sign up page, the background page, and you can do this all in real time. Okay, even the email templates you can change, like welcome to my system, click here, pay the bill, send the credit card, you can do whatever you want. And then if you click here, you go to this part here. Okay, so that's the sign up page. Very good. Is up to you what you're gonna have here. You can change, eliminate, I mean, you can change the title, you can eliminate here tago.io if you want. Okay, that is where your customer is gonna sign up here. okay? And then when you deploy your application, you start with one. Again, if you did a smart application, machine learning, you did something, getting data from the sensor, process, generate reports. You have a lot of example how to generate reports. You get all these, you are able to deploy so that your customer is not going to access Tago. They not even know that Tago exists. They're going to go to here, okay? So for example, if you say that you have a new customer and his name is Paul, okay, the email is like this. I hope this guy's gonna receive the email from me now. Okay, so you create here. Okay, so when I do that, if I come into the list now, I see that Paul McCoy is here, okay, but it's not active. So let's active because this guy really doesn't exist, is here, okay. And what you see here, that the system already created the tags, okay, because there is a rule that defines and generated the tags. I'm not to give you all the details here, but basically pretty straightforward. Also create the ID. So the customer is okay. So if the customer coming here now, and I think that's the name. Okay, hopefully that's the right password. Okay. So the first thing that this person is gonna see is this screen. There is no sensor connect. So nothing's really working his account because he still need to create a sensor. So let's put a sensor here is like a Mac station and create a serial number. This serial number maybe is the station that he has in his mind with a serial number like a MAC address or a serial number from cellular or from LoRa, for example, okay? Then you create, when you do that, you see that this person now has the sensor. So what you have done here is really associate the new devices with the users. So if you have more users come to your application, it's a matter of get your devices ready to go and allow them to claim this device. So if, for example, if you're selling your sensors at Amazon, they can buy your sensor when they receive it at home. They can come to this screen or another screen, is up to what you're gonna do. Ask them to get the serial number and the name, and that's gonna show up here and the station be up and running. So if you go back to the developer side, you should be able to see that this person here already has a device, and you see Mac stations here. So he creates the weather station in his side. If he add more another one, look how interesting this is. If I add another one, okay, so just think about how to scale. So now is my wife station. Then add the serial number. Of course, it should be a valid one. Here's just an example. Okay. You see that there are options here. There are two stations here for the same user. So that's one way to show how you can scale. We have videos in detail showing how to add each field of configuration. But again, that's one way to make sure you get your application not only up and running, but also started to scale, because again, that's where normally everybody wants to go eventually. They really want to have more and more sensors. And you could see here that you can create your dashboard, you can add the tags, and then you can start to scale. So if you have 1,000, 10,000 of these stations in the field that are devices connected to the network that you select, your customers will be able to scale them up. Okay, Caroline, so this finished the key presentation. I'd like to know if there is any question.
Hey, Fabio, wonderful presentation. Yeah, we do have a couple questions here. The first one is, do you have an MQTT connector, or do I have to connect to a physical device?
Yeah, that's a very good point. So if you click here on the top right, you see a question mark, and you can do that. You can type like MQTT, And answer the question, yes, of course, we have MQTT. We explain how to do that, and you have a lot of videos in our website that explain how to connect anything using MQTT.
Wonderful, thanks, Fabio. Next question. Since the sensor solutions are low cost, do they have any security features to prevent intrusions and protect the data gathered?
Yeah, no, that for sure is important. When we saw, by the way, I list the top reasons why project didn't work well, at least as expected, and security is very low. That's interesting. Maybe, you know, a long term, of course, I don't mean that's not important, it's the most important thing, I would say, right? You want to keep them. But these chips today, they have very interesting feature, like double authentication from both sides with certificate. So we can use that. Also, everything is encrypted, so use HTTPS as well. Again, talk about the experience now. That's really about the customers. And sometimes what you see that customers are really to put this together, and they don't have all the certificate yet. They are in different levels. So very inexpensive devices can have a very high level of security, but it's just new. But it's possible, of course, and we always work with that. The same thing for the database. All the data is scripted. So, of course, only you have access.
Thanks, Fabio. Next question here. How is data transfer protected between sensor and storage?
Everything is encrypted. We have more information here. Should type about security, but basically the data is left encrypted. For example, if you get the, let me show you here. Okay, the presentation, just a second. So if you go back to this slide here, to this ecosystem. Okay, so if you see here, the sensor, the data is leaving the sensor here. It's go encrypted here to the gateway, to the network, to the database. Okay, we worked with the network server providers around the globe. We have more than 13 of them, and they're pretty big. And each one has a little bit difference, but there is a standard for LoRa 1, and also for Sigfox. So everything is encrypted from here to here.
Thanks, Fabio. This next question is to understand integration with third-party solutions. What data format is used for transferring data between the sensor edge device and the storage server?
Yeah, we have APIs. We have APIs basically for everything. So you type here like API overview or send the data, okay? So that's interesting. You can use this to send the data from one device. Let's say that you are creating your own device. And by the way, we would love to talk with the company that created devices, because we have a plan to have 1,000 different types of devices by the end of this year. We will create a partnership program. So go to our website, contact us. So if you have a device, you want to send the data, use our HTTP or MQTT or another mean, right? If you want to collect the data and update the data, delete the data, read, get, you can also use our APIs. We use JSON, but in some case, if you need special connectors, we have situations that we have special connectors for the database as well. Our documentation, I think, is pretty good. Also have the community. If there is question, we have an open channel between anyone and the ticket. So if people has questions, they come here and they say, okay, I need the help because I don't know where to get the information. We will be glad to come and allow them to open a ticket. And we try to be very fast replying tickets. So if we get to support, you can come here inside and type something like APIs, for example. And you can see right away in our community, a lot of people talk about the APIs right now, some time ago in this case. And If you still want to send open a ticket, we'll be glad. Even if you have a free account, we'll be glad to answer, jump and help you.
That's really helpful. Thanks, Fabio. The
Yeah.
next question is, do you work with the emerging helium hotspot network?
Yeah, that's a good one. We heard about them. We met them here, I think last year. I know that they have changed now, the kind of the model they're using, more focused on LoRa than before. That's my understanding. We will going to be discussing with them a way to integrate it for them. Right now, we have a lot of companies here in the area. By the way, maybe people not even aware, but at close to Centennial Campus or Centennial Campus, we have antenna with a LoRaWAN coverage. We have different companies. We have our own gateways. But if people want helium, we need to check two things. First, maybe there is a way to send the data direct to us just by using our endpoint. That's a possibility. If it doesn't work, we need just to do a connector for them. Okay, so if someone has interest, it'd be good to send us information, create your free account and ask us, because we are really collect all these to make sure that we prioritize which are the most relevant integration, because there are so many ways, so many things that we should be doing. But if people has interest in a specific topic, just contact us.
Thanks, Fabio. The last question that I'm seeing here is, what kind of LoRaWAN gateway was used for your example for asset tracking?
Gateway, I think physically is a Carolink, and the network provider is Evernet. Let me show you here 1 second. It can be two different things, because the sensor is what we care. Is really that's what you parse the data, extract the data. The gateway is in the middle, and normally from the gateway it go to a network server. Okay, so in this case, we have here data coming from that one with Evernet. Is one of the company that we work a lot. Okay, but it can be the same thing with a TTN or TTI. That is basically no difference. But if you ask physically, in our office here at Centennial Campus, we have Carolink, we have I think Multitech, and yeah, and the others in our office. Tectality as well is a big one.
Wonderful. Well, thanks so much, Fabio. Just great presentation. Really appreciative of your time. I just want to thank all of our speakers today. Lori, Daisy, Andrea, and Alex from Code the Dream, brought to you by Google Fiber, Steve and Tom from SAS, Ted at Clario, and Fabio from Tago.io. And of course, a very special thank you to Tina at Dual Boot Partners for sponsoring today's event. I encourage you all to stick around for the networking hour. Please feel free, or half hour, please feel free to turn on your cameras, unmute yourselves, interact with each other, ask our speakers some questions and connect. And in about 15 minutes, we'll announce the prize winner for today, brought to you by Dual Boot Partners. Thanks again, Fabio, and all of our speakers.
Thank you.
Don't be shy, everybody.
I think being at home is exactly why people are shy.
Yeah, exactly. Well, thanks to everyone for attending today. I appreciate everyone taking time out of their busy schedules. Next week, we have great speakers as well. We have the NC Business Council, Spanalytics. I see Mark join us today. Mark is a great speaker. He'll be joining us from Spanalytics, Charlotte IoT, and Cisco. So exciting speakers. But yeah, please feel free to chat with each other.
Hey, Caroline. This is Steve. I heard a couple of questions just about the helium network, something that we're just getting started and looking at. Anybody have more information on that? Or obviously I can hit the website, Helium Networks, but in terms of information and experience, I don't know if it was, who exactly it was, Lisa or others that might have asked about that. And it sounded like, Fabio, you had either worked with some of those folks or knew about the devices there. Any background on that or insight you guys can provide? Maybe to the rest of the folks on the call too?
Yeah, just put clearly, here's Fabio. I haven't worked with them directly. I'm not even connected here. I talked to them, but I think that's a very good point. I'd be very excited to know who else is using, because I was in the website before, and I know that there are some already active here, right? You can see each one.
Mm-hmm.
Yeah, but I have no details. I'm very, very excited to know if somebody else here is working.
Right. Okay, yeah, me too.
Hi there, this is Lisa. I'm in Connecticut in the New Haven area, and I'm a new helium hotspot owner. There are maybe 10 or so in the New Haven area, and this is an initiative. It's called the People's Network. So people would put a hotspot in their home or workplace as a method for IoT devices to connect to the network. Part of an incentive for people to put these devices in their home is you can earn helium network tokens, which are H&T, which is a kind of a cryptocurrency. The network works on a proof of coverage algorithm. So the hotspots have to talk with one another to ensure that they're in radio frequency range of one another. My new hotspot is not connecting with any others. I've got a couple of mountains and hills near me, so that's a little frustrating, but there are, I think, over 8,000 nodes now in the US, and over 8,000. And you can go to explore.helium.com or network.helium.com, and you can actually see the different locations of the hotspots. It works on challenges and consensus groups and things of that to generate these tokens. So I urge you to maybe go to the site and learn more about it. I'm still a newbie as far as I'm considered, and trying to learn as much as I can, and that was part of joining in today's discussion. Because I work at a university in New Haven, and we're trying to get students excited about the IoT movement, and I was trying to find out different use cases. So I thought that today's speakers were really exciting to hear what they're doing and the potential of all this. So I'm happy to try to answer any questions, but I don't know if I'm the expert. There's 8,254 hotspots in the US, and they're also releasing them in the UK as well.
This is my ConComp down here in Raleigh from Aero, Lisa. I was curious, is this more like of a LoRaWAN or?
Yeah, it's all LoRaWAN, right?
It's all LoRa.
Yeah.
Gotcha. Yeah, I think the LoRa stuff that we've done around the Raleigh area actually works probably a little bit better maybe than your area because of the lack of hills and you're still going to have the dips and valleys and things of that nature. But, you know, some of certainly out here in the Wake Forest area anyway, you know, we have, you know, 1,000-foot tower that really helps out with that.
Yeah. Yeah, well, I've been climbing on my roof every weekend trying to get a taller antenna. This weekend, I'm going to try to attach it to an old sailboat mast and see if I can get over a couple of.
Well, be careful.
Yeah.
Yeah, exactly.
It's been fun to watch. You can still participate in the network through just regular internet connectivity, but it's been very fun to get to learn more about it and the potential of it.
Interesting.
Yeah. Yeah, absolutely. Yeah, I was intrigued by some of those questions about it, so thought I'd ask the rest of the group, see if anybody had stuff to share. So that's good. We'll definitely be checking that out.
Thanks for asking, Steve. Thank you.
Sure.
Helium is in our partner network, and they did a lunch and learn recently. You can find the video of it on our YouTube channel, so I'll post that here for anyone who's interested.
Yeah, great. Oh, that's perfect, Caroline. Thanks.
Charlotte,
Caroline.
this is in Charlotte. We are trying to put the gateway at UNCC. So we are working. Any of you presence in Charlotte, Fabio, or others, presented, so we can also work together. We are working on behalf of Makerspace to. I will run a class there actually, but we are excited, to expand the LoRaWAN, all the activity here in Charlotte also.
Great.
Wonderful. Thank you. I know that Tina is on from Dual Boot Partners from our sponsor for today. Tina, if you have any words to say about Dual Boot Partners, sorry, say that fast 3 times in a row. We'd love to hear from you.
Sure. Well, thanks, Caroline and RIoT, for having us. We were happy to sponsor today's event. So a little bit about us at Dual Boot Partners. We build customized software for both the web and mobile applications, so the conversation was pretty relevant. We also do some staff augmentation for software projects and replatforming of legacy code. So if you have software needs and you want to discuss, feel free to reach out with me. I'll be happy to chat. But thanks for coming. This was very interesting information.
Thanks so much, Tina. Everyone here, I know Gopal said he's in the Charlotte area. Everyone else, and you're in Charlotte too, right, Tina? The Charlotte area?
We are headquartered in Charlotte, but I sit in Raleigh.
Okay, yeah. I'm located in Raleigh. I didn't know if anyone was joining us from outside the RTP region today.
Yeah, I'm meeting with our friend Brett from Samtech this afternoon. He's helping us for the Charlotte actually. So I'll talk to him about this helium. Somebody posted the largest LoRaWAN network. So thank you.
Yeah, I just posted a very interesting thing. They have something called the Helium blockchain, but they're swapping out the native protocol, the LongFi protocol, to LoRaWAN's protocol, which is supposedly more reliable. But I'm an old amateur radio operator, so it harkens back to my packet radio days where we did it over HF, and so it'll be interesting to dig deeper into helium.
Absolutely, guys. If you're able to join us for week 5 of Developer Day, Chris Meyer, who recently joined RIoT's team, he also owns a company called HardShare, is going to be demonstrating some of what HardShare's capabilities are. And I believe you guys use some of Helium's product. Is that right, Chris?
Yeah, well, we use, yes, we do. That's the short answer. Yeah, so we use a Helium base station hotspot as part of our demonstration, but primarily we use ST Micro's LoRa discovery boards as part of our offering here. But yeah, Conrad, I've been pretty deeply integrated with some of the Helium stuff. If anybody has any other questions about it, I've had really good success, with the LoRaWAN protocol. Previously to joining RIoT, I also did has anybody seen the little LoRa coasters? Conrad, I don't know if you've seen those. I'll drop a link in here.
Okay.
But we did a little workshop with these coasters that had a temperature and pressure sensor that would backhaul the data over LoRa So that way you could distribute them in something like a pub to see like how much and what the temperature of the beer that people are drinking. So it was kind of a fun little project. But it's a lot of neat stuff happening in that space right now.
Very nice.
Yeah.
Thanks, Chris. And a correction to Amber's earlier statement. Chris will be in week 4 of Developer Month, so I'll post the full schedule here for everybody.
Thanks, Caroline.
Chris, there were some questions about helium. There were some questions about helium earlier. If you want to talk about your experience with helium, or
Yeah. So
any specific questions, feel free to shout them out to Chris.
yeah, so for context, I've done a number of projects within IoT, and generally the limiting factor has always been how to get data off the devices. So Wi-Fi generally is like pretty narrow area. Bluetooth, I know that there's been a ton of advancement into Bluetooth, but the range and the reflections of signals was always problematic for me. And then with cell backhauling, you have a per device fee generally associated. And this is why I'm really excited about helium, especially for sensor networks, is that it's really, you don't have a per device fee to backhaul data. The transmission costs on helium in particular are super cheap. I think right now it's 100,000 messages for something like a fraction of a cent. So it's very, very, very low price on helium. And then there's other ways that you can actually set up your own infrastructure. But anyways, I've been in this space for so long that I'm really excited to see the distance, technologically speaking, to do broad mesh networks of sensor data. So really exciting stuff.
Yeah, and this part of LoRaWAN is really great, because you can really release your solution a private or public network. That's really nice. Here, we have a coverage from Senet here in Raleigh, for example. We have customers here using. But also, if you wanted to create your own network with your own gateway anywhere, connect to satellite, like you have a customer connect to satellite or Wi-Fi or 3G, LTE, you can also do that. I'm assuming, Jeff, that with Helium, you can connect any sensor that's LoRaWAN protocol certified. Do you know that?
So the LoRaWAN protocol is more for the transmission of data. So if you generally you have a sensor in tandem with a microcontroller of some sort, right? Yeah, so there you go. You got it.
We have it here. Yeah.
Yeah. So I think at least on Helium, I think it's 51 bytes per transmission. And so depending on your encoding method, you can, it's pretty easy to do. But yeah, I don't know. I geek out over this stuff. So I'd love to maybe grab a few folks and just ideate on what we could do together.
Yeah, no, that's great. Yeah, if somebody wants to test that, I'll be glad to give access of the entire platform. And we have developers here. I'm very excited to integrate this with us. Should not be a problem. I don't see, but just need to get our guys to take a look in the details to forward the data, because you can send the data, also send it back to the device, right? So that's really cool.
Yeah. And so that's the uplink is really interesting to be able to do that.
Yep, downlink.
Yeah. It looks like there was a question in here from Jim. I have not seen. So the question is, have you seen the new Helium tracker? I haven't personally, but Helium is actually a RIoT sponsor. And so I've been keeping in touch with some of those folks, and I think they just got theirs. So it's going to be a really interesting thing. It seems to me that could fulfill the promise that Tile was trying to do back in the day with their Bluetooth trackers. So I'm pumped to see those as well.
Oh, you mean the tabs, the small one, the tabs?
Yeah.
Oh, we have some here, but I'm home today. But I have in the office some tabs. It's really cool. So I have with magnets, with location. Yeah, you're right. Yeah. It's pretty far, right? It can go, I don't know, 50 yards or more, depends, right? That's really nice.
Yeah. It's pretty neat. So it'll be interesting to see what our lives are going to look like in the next few years.
So Fabio, and just talking about those trackers like Tile and these helium trackers, you were looking at asset optimization and the pallet tracking as one of your examples. Is it a similar device they were attaching to pallets for that solution? Is that what they were doing?
Yeah. That's specifically, unfortunately, I cannot give you much detail here. I would love it. And by the way, if somebody wants to send me information, I'll be glad to contact with the company. I think they have no problem, but the customer, you have a problem. But basically, it's very small, size of a coin. And it's really just an antenna, the LoRa, and kind of some sensors like accelerometer inside. That one, but specifically done by company is I think it's a Chinese company, but with the engineers here in Texas or Atlanta, and we work together, and they are expanding that one. So in the very low cost, really nice.
Okay, good. Yeah, one of the examples I mentioned in the beginning was around hospitals and the connected healthcare and asset tracking in hospitals. Same exact application, whether it's pallets or glucose monitors or high-tech beds. Same idea. I want to know where they are so I get maximum utilization out of those into assets I've invested in. So yeah, I was really intrigued by that story. So I may follow up with you on some of that and maybe bring Chris and some of the other folks in on just to have a collaborative discussion and kind of talk things through.
Yeah, that's a good point because, there is also the one with the beacons, right? So if you want to run indoors, right? The global side, they have very good work job. Paycor, no, not Paycor, I'm confused. Is that orange one? I had here somewhere, but yes, send me an email so you can get indoor, outdoor. Some has GPS, others don't. So
okay, good.
Again, our goal, we are a member of a lot of alliance now, and we are really working for them to add really 1,000 devices. So it's frankly, I believe there are 1,000 around, but our goal is really to bring everyone. So we automated that. We want to bring all the sensors. So it's like if you sell the hardware, it should be ready to connect with us. And they can connect by themselves. We don't need to create them. We have a nice portal coming the next week. So I really encourage you guys, send me an email, fabioer@target.io in the website. Let's talk about it because I think that's a great place here with RIoT to talk about that.
Yeah,
perfect.
And then out of curiosity, because I was just made has anybody used the RAIN RFID protocols? No? I am fresh to the tech, and I think I was going to call on Amber, see if she could talk about Trilliot and any of that stuff.
All right, Chris, would you ask that question again?
Oh, sorry. But the RAIN RFID tags that I think that Trilliot is using?
Yeah, I don't know too much about the specific technology, but Trilliot went through RIoT's RAP program 2 cycles ago, maybe 3. I can't recall off the top of my head.
They were in the first accelerator program.
Caroline, thank goodness you are here to fact check us. Or fact check me anyways. But Trilliot focuses on asset management, and he has a great product using those RFID tags. They've kind of taken off quite a bit, especially in the automotive industry. He's looking at making some contacts there and some contracts as the automotive industry has decided that asset tracking is becoming an integral part of their manufacturing process. I know that does not answer any of the question or interest, but that's what I know about Trilliot. And we can certainly post their information so you guys can reach out and make that connection, or we'd be happy to foster some introductions for you.
Yeah, and from my perspective, the problem being solved is abstract, right? You want to know where something is, when it moved from one place to another, and how to find it quickly. And so this is where in IoT in particular, there's all these different technology stacks that can support that, but just depends on the installation. I was recently talking to a company called Parcel, which is doing cold supply chain monitoring for vaccines. And so for them, they can get by with a data logger, but as they have like higher requirements for where is it at any given point, then we start to layer in different types of edge conditions and sensors and that type of thing. So it's really interesting, like all the variations of something as simple as I want to know where something is. So yeah, it's a really fascinating industry right now.
Yeah. So Caroline, is fine. I can post here a webinar that I'm gonna do with the Tactility. I don't know if they are a sponsor, Caroline, but I think it'd be, Tactility. I think you guys, I talked to them. They supply gateway and also sensors for asset tracking, for home sensors. Unfortunately, I'm not in the lab. I have all of them. They send it to me, a lot of sensors. I'm fortunate to have. So I will post it here, guys, to everyone who have interest to attend this webinar. So I'm going to talk about cases like this that you just mentioned, Chris, and also, they are from Canada. They are with a very nice line of products for LoRa, with beacons and indoor soil sensor for agriculture. If somebody from university here, I think it's really cool. So that's the registration, but the company is called Tactility.
I used to teach at NC State, and I had students on several occasions use LoRa, and they really did a really good job of it for several different applications in agriculture and water monitoring for municipalities. But what was very interesting is we would always discuss use cases in the very beginning. And the students would say, yeah, and they would immediately dive into technology. And then during second semester, I was always going back, and we were having to have much more detailed review of the application, the use cases, because they had not appreciated as much as it really was.
Mm-hmm.
That was true over half a dozen times. And it was interesting as a learning curve to see that it wasn't the technology, it was the use cases that were more the thinking limitations, just like Chris was saying.
Yeah, so I think if you go back to Chris's example of beer drinking and coasters for college students, I think now you're going to get their attention. Now they'll be—
that would be more effective.
Yeah. Well, maybe Caroline knows this, and again, fact checker in real time here, but didn't RIoT do one of the rounds, I think it was the RAP program, but monitoring the beer taps and the beer flows, and that was helping bar owners basically understand when certain kegs would be empty first and not just run out and have to scramble and react, but be more proactive. Chris, I say we marry that with the Coaster app and start identifying, not only what's flowing, but where it's being consumed and how quickly. And so now you've got a real app. So
now you have my attention.
That's right.
That sounds like a great idea, Steve. Yes.
Yeah. Perfect.
Awesome. Before we run out of time, I do want to announce our winner for the day. Lisa Lancourt, you were here the entire time. Thank you, Lisa. You are the new owner of a water-resistant, anti-theft, smart travel backpack, courtesy of Tina and Dual Boot Partners. So congratulations to you, Lisa. And I'll put my email in the chat. And if you just email me your address, I'll have that sent over this week.
Great. Thank you so much. I rarely win anything, so this is great.
You're welcome. It's all from Tina and Dual Boots. I think.
Awesome.
Congratulations.
Enjoy.
Thanks, Tina. Appreciate it.
Well, we certainly have a few more minutes, but I just want to thank everyone again for being here today. I hope you're able to join us for the last 3 weeks of Developer Month. Thanks again to all of our wonderful speakers and for staying around. Really great. Appreciate you guys.
Yeah, and keep in touch. There's so much happening, and the more conversations we have, the more we're aware of what's going on.
Exactly. All right, great. Thank you.
Thanks all.
Thanks again for having us.
Thanks so much, Tina.
Thanks, Tina.
Yeah.
Yep.
Good job, Caroline. Thanks for hosting.
Thanks, Caroline.
Thanks, Mike. Our lovely local representative from Aero Electronics, Mike Honkamp.
Yeah, if you guys need any hardware, let me know.
Yes.
We
I'll be
always
happy to
need
connect
hardware.
you.
Yeah, we always did.
Exactly. All right. Thanks, guys.
Awesome. Thanks so much, everybody. Take care. Stay safe.
Yeah.
Stay safe. Bye-bye.